Well, hello everybody, and welcome to our presentation today on an introduction to networking technologies. Brought to you by yours truly, Internetworking Experts, otherwise known as I&E, and I will be your instructor today. My name is Keith Bogart. In the event that you have not seen me before, or if you have any questions regarding this, just want to give you my contact information right here. So here you can see my email address, my Twitter account, and my LinkedIn. So as we go through the presentation today, I will be pausing frequently to see if you've been submitting any questions via the YouTube Live instant messaging or the feedback tool built into YouTube Live. But in the event that I don't get to your question, either because there's just far too many questions, there's a sudden earthquake, hurricane, whatever, and this session comes to a close, I don't want you to despair. You can reach out to me here via my email, Twitter, or LinkedIn and send your questions that way as well. Now also I want to show you, ideally though, if you have a question that's not answered today, I would like you to post your question within our I&E online community, because that way other people can benefit by seeing your question and seeing the associated response that came with it. Keith, what is the I&E online community, you might ask? Good question. So let me show you where that is so you know how to get to it. So if you do not have an I&E account, you will need to get one. It's absolutely free. You don't have to provide your credit card, blood type, social security number, or anything like that. So if you don't have a free I&E account, so just go to ine.com. That's clearly our website. And in the upper right-hand corner, just click on Login. And it'll prompt you to create an account, create a username and a password. All you have to supply is your email address, and basically that's it. Now, once you've got that, from the main homepage here, you can scroll down, and the I&E online community that I'm referring to is located down here at the bottom. So right down here, under almost this last link here, IEOC Forums. So that's what you're going to want to click on. All right, and from here, any questions that you have that are related to today's show would probably go under the section of Cisco CCNA. So you would want to click in there, and then just post your question under the second heading here of just CCNA, just general CCNA questions. And you can put it in there. And the vast majority of time, like 99% of the time when a question goes in here, within 24 hours or less, either myself or somebody else will respond back to you. There's a lot of people that are sort of watching this online community, and so any question you put in there should be answered. Now, on the off chance that your question goes a day or two and you don't get an answer, well, number one, it could be because of the way you submitted your question. So if you submit a question and in the title of your question you just type in question, no one's going to want to answer that. No one's going to want to read that, because that could mean anything, and people are far too busy to read through that. So tip number one, put a meaningful title into your question, something short but something that sort of describes the nature of your question. And then go ahead and type in your question. And then secondly, another common reason why people don't answer questions in here is because your question is just way out of the scope of what this forum is used for. I need to get a job. Can somebody help me? Well, that's not what this forum is used for. Or you're asking a technical question that's so technical it's way beyond CCNA level and it belongs in another forum for a much more technical certification. So those are the main reasons why questions don't get answered. But if you feel that your question is valid for the show today, it's at the appropriate level, you put in a meaningful description or title and still you don't have any takers, nobody's responding back, well, then by all means, in that case, feel free to reach out to me directly and I'll do my best to answer your question as best I can. So let me talk a little bit about what I'm going to be talking about today. So I worked up this little paragraph here to sort of describe the objectives of the session today. For those of you thinking of pursuing a career in computer networking, or maybe you're not thinking about pursuing a career in computer networking, but you just know nothing about it and you'd like to learn something about it. You'd like to sort of shave off some of the fuzziness around this term and you want to know a little bit about what it is. Either way, This course will help you to identify what is a computer network, why do we use them, what benefits are there to computer networks, what are some of the common components in a computer network. So by the time we're done with this, you'll be able to look at your computer, that cable leading out of your computer, going into that box with all the flashing lights on your desktop in a totally new way. You'll start to understand what all that stuff is used for and what's going on. So these are the things I'm going to talk about. I'm going to take periodic breaks throughout these topics here to answer your questions. So I'm going to start out with what is a computer network, the common components of a computer network, some technologies that make up a network. You know, what are these things called switching and routing and Wi-Fi? What is that and where is it used and why do we use them? We'll talk about that. And then I'll talk about some computer networking job roles. If this truly is something that interests you and you think that, hey, maybe this is something I'd like to make a little bit of money off of. Maybe I'd like to go work for a company doing this kind of thing. I'll talk to you about some job titles that you'll see, you know, at dice.com, indeed.com, whatever job site you use, and sort of what common expectations there are for those different job roles. And then lastly, I'll finish up with, where do I go from here? You know, now that you've watched this and I've whet your appetite and you want to learn more, what do you do? So that's sort of what I'm going to talk about today. So my prerequisites for this are pretty darn simple. I basically, you have to be alive and breathing and have a heartbeat. That's number one. You have to know what a computer is. Okay, I'm assuming because you're watching me, you know what a computer is, and you have to know how to use a web browser. So the very fact that you're watching me right now means you're good. You meet all the prerequisites. So let me sort of give you an idea as to, you know, right now I'm just facing a camera. I don't see any of you people out there. So in my mind, as I go through this, I'm going to be sort of envisioning that I'm teaching this to my grandmother. Okay, my grandma who just knows how to bring up her laptop. She knows how to go into her Gmail and check her emails, and she knows how to open up this window we call a web browser. She doesn't know what it is, but she opens up this window and from there she can like go to Pinterest or, you know, whatever. And that's all she basically knows. So I'm sort of gearing today's presentation towards her. All right, if you know more than she does, great, you're ahead of the game. All right, so before I get any further, I'd like to see if there are any questions from you guys. So let me just go ahead and check that out. Sorry, folks, I was on the wrong page. There we go. All right. Now I can see everybody. Great. How can I get a networking job without experience? Well, short answer is you probably can't. But when I get to the end, of this presentation about, you know, where do I go from here? Repeat your question at that point and I'll address that a little bit more fully. Mohammed, unfortunately, I don't know anything about the CCNA Cyber Ops exam. I know it's very closely related to CCNA security. I have somebody that went in, I had a boot camp I held here in Raleigh a couple of weeks ago, and someone who sat in that boot camp actually went through the CCNA Cyber Ops. They had also gone through the CCNA security, and they said that CCNA Cyber Ops was very, very similar to CCNA security, but from their perspective, and I'm just telling you what he told me, he said that CCNA security was more in depth than CCNA Cyber Ops. So that's all I know about Cyber Ops. I can't help you out with anything other than that. And 3D0. Let's see here. You say you've got a CCENT. Great. And I'll talk, for those of you who are wondering, what is a CCENT? I'll talk about what that, but it is sort of like the baseline or very first certification you would get from Cisco Systems. And you're studying for the ICND2. What type of networking job could or should I look for versus having a CCNA? Well, without having a full CCNA, without having passed the ICND1 and the ICND2. Really, the best kind of networking job you could hope for would be to be like an intern, honestly. I don't think anybody would hire you as a network admin without a minimum of having a CCNA and some experience. So with what you have right now, I honestly don't think you're going to get a job as a network admin. And once again, you might be wondering, what is a network admin? Well, I'll talk about that. That's in my job roles section. I'll get into that. All right, so let's go ahead and move right on here into the topics. So I'm going to start out from the very baseline here about talking about what is a computer network. And I'm going to talk about the common parts of a network, the very basic minimal parts you would need to put a network together, some common words or terms or vocabulary that you need to know, and why do we need these things called computer networks? All right, so before I show you this next slide here, a computer network doesn't have to be this big, monstrously complex thing with tons of devices and cables running for miles. I mean, it could look like that, but technically speaking, at a very generic level, a computer network is simply the physical thing, maybe wires and stuff, but the physical thing that allows two electronic devices to exchange data, to exchange information. That's it. Okay? Now, what that thing is that connects device number one to device number two, that could get very complex. But at its very core, it could just simply be, okay, in device number one and device number two, we're going to put in some special software. We're going to make sure that device number one, device number two actually know that they are connected to a network. They have to, the devices themselves have to know what a network is and they're connected. Then we have to put some special components, some special cards or adapters inside of these devices. Now, these devices could be two laptops, they could be two tablets, two smartphones, any two electronic devices. Okay, they have to have special networking software, number one. They have to have special sort of interfaces to the network. And then you have to ask yourself, what is the physical media? What is the physical thing that's carrying the information back and forth? Now, as of today, there's basically three main primary types of things that compose the network. There is copper cable, right? Just regular cabling that carries electrical energy, electrical signals. That's probably the oldest form of networking. There is fiber optic cable, which on the outside looks like a regular cable, but if you actually took a razor blade to it and you opened it up, you would see that there's no copper, there's no metal inside of it. The cable itself is actually made of very thin strands of fiberglass or maybe plastic. And what's going through there, the data that's going through a fiber optic cable, it's not being carried by electrical energy, it's being carried by light waves. Okay, that's fiber optic. Where the third most prevalent type today is the air, right? When you're doing wireless, when you're doing Wi-Fi, there is no cable. Your physical media or medium that's carrying your data is the air itself. So depending on which one of those three types you're going to select to connect device one to device two, that will determine what your component or what your adapter is that connects to that network, right? So if I'm using copper cabling, I can't have this device here have something that's designed to talk to Wi-Fi, talk to the air. No, it's got to have an adapter that connects to that copper cable. And similar for fiber optic cable and similar for Wi-Fi. So that in its very basic essence is what a computer network is. It's the software running the devices, the adapters that connect to the media, and then the media itself. Copper cabling, fiber optic cable, or the air. So that's your basic network. Now, of course, it can get bigger and bigger and bigger. So let's sort of look in this slide right here, let's go through some animations that sort of describe the evolution of how networking grew. So in its very early days, okay, so back when copper cabling was invented, okay, copper cabling for networking. So we're talking the mid to late 1970s. All right, and I recognize that some of you guys watching me weren't even born at that point in time. So just imagine yourself back there, right, with the big collars. You just came back from the disco and the disco ball, and now you're going to connect to the network. What did that look like back then? Okay, well, first of all, You didn't have any laptops, you didn't have any tablets, you didn't have any smartphones. The computer you had was this big monstrous thing that took up half of a room, which is called a mainframe. And if you were sitting in front of that mainframe, chances were that you worked for like a university, or you worked for some sort of scientific organization or something. The typical Tom, Joe, and Sally out there knew nothing about mainframes, never connected to it. But let's say that you're working at a college, you're a professor, you're a scientist, you go into your building and you've got this big mainframe in one room, and you want to connect that mainframe to another mainframe in the floor above you, or the floor below, or the room next door to you. So you have two monstrous computers that need to talk to each other. All right, back in those days, how did you do it? Well, you had copper cabling, real thick copper cabling, very rigid, it didn't bend very well, and you connected. So those mainframes had to have special software that understood what a network was. They had to have network adapters that connected to that copper. Now let's flash forward a little bit more in time. Now we've got PCs. Now in this particular picture right here, we've got PCs and laptops. But imagine that these users here in Department A and Department B are both sitting down in front of like really old computers, right? Like the big tower computers with the big monitors that were like this thick. Okay, so that's what they're sitting down in front of. And what a network looked like then was still their individual personal computers, PCs, had networking software installed. It had a networking adapter that connected to a cable. So you had one long cable, and each PC, each computer was tapped into or connected to that cable. So in this case, we've got two pretty small networks. We've got Department A's network, which only has 4 devices, and Department B's network, which has 4 devices. Very simple network, okay? And as Department A got more and more employees, those new employees would just tap into that one length of cable. All right, so the downside with this is that, when 2 devices, let's just start with 2. When 2 computing devices, 2 electronic devices are connecting to a network, forget about whether it's wireless, wired, whatever, they're connecting to some kind of network. Well, there have to be some rules put into place, and this is what the networking software does that's sitting in those computers. There has to be some rules in place that answers questions like, when are you allowed to transmit onto that networking media? Can you transmit whenever you want? Do you have to wait until the media is free and nobody else is talking and then you can talk? Rules about once you start transmitting, can you just keep going and going and going and going, or do you have to stop after a certain amount of time? And if it's after a certain amount of time, how much time? Rules about, okay, well, if there's a whole bunch of devices, not just 2, if there's several devices connected to this network media and data is coming into you, you're receiving it, how do you know it's for you? As opposed to John's computer over there or Sally's computer over there. So networking software answers all of those rules. Well, in the original early days of networking, where everybody was connected to one cable like you see here, the rules were very simple. The rules were, hey, even though you've got some data to send, you got to put on this wire, you have to first listen to the wire. Make sure it's quiet. This is sort of like we do in human society today, right? If you're sitting around the dinner table and you want to talk, what do the rules of polite society say? They should say you just sit there, and when there's a pause in the conversation, then you can talk. You shouldn't talk over somebody else. And if you do talk over somebody else, chances are nobody's going to understand what you said, because the 2 people talking, their voices just sort of merge together and you can't tell what one person's saying. So in the original days of networking, one device couldn't talk until everybody else was quiet. And then it could start putting its energy on the wire. In this case, it could start sending its electrical energy, its electricity on the wire. And as it was talking, everybody else had to be quiet. It was, for example, let's say we've got here, let's say we've got Bob right here, and Bob is now putting his electrical energy on the wire. Well, if at the same time, Sally right here, she starts putting her electrical energy on the wire, right here where it meets, that means that electrical energy is colliding. And when you put electrical energy on the wire, it has to look a certain way. It has to conform to certain rules so the person who's receiving that electrical energy can make heads or tails of it. They can tell what kind of data it is. It's just not random electrical noise. Well, when two people are speaking at the same time, like this, and they run into each other, that renders this electrical energy meaningless. So the early rules of networking said, hey, if I'm talking, nobody else should talk. I have full and complete control over this wire. And if somebody does happen to talk at the same time as me, if they put their energy on the wire at the same time as me, that is considered a collision, which means I have to stop midstream, stop halfway in my conversation. I have to wait and then try again. Well, if we only have, like this shows here, 4 devices on the cable, not a big deal. Things will work pretty smoothly. Every once in a while, devices will run into each other, but this stuff happens so fast that you, as the actual human being on that computer, you wouldn't detect that there were any problems. Everything would go fine. The problem is, as this cable gets longer and we add more and more and more and more and more devices to it, well, now we start having some significant problems. Because now Bob over here, when he wants to put his electrical energy, when he wants to transmit information on this cable, remember his rules say you can't talk on the cable unless it's quiet, unless nobody else is talking. Well, as we add more and more and more devices to this cable, the likelihood that the cable is free, that it's idle, that it's quiet, becomes less and less and less. Now Bob is having a problem because he can't get his information on that cable very often because it's so busy. And let's say he just happens to get lucky and he squeaks in there. Okay, it's free, nobody's talking. He starts squeaking in there. With these many devices on the cable, now there's a greater likelihood that his electrical energy will run into somebody else's electrical energy. A greater likelihood of collisions. So, but this is the way early networks were. One cable, everybody tapped into it, and the bigger it got, the more risks there were of problems. So some very smart people said, wouldn't it be a better idea if instead of having one cable that everybody is connected to, everybody is sharing, what if we had every computer have its own separate cable and all those separate cables merged in one common networking device? And what's kind of neat is that this networking device here will be set up in such a way that if two devices connected to it talk at the same time, well, if they were on one cable, that wouldn't be allowed. They couldn't talk at the same time. But if they have 2 separate cables and they're connected, so for example, if we put Sally right here and she's got a cable, and we put Bob and he's got a cable, and they're both connected to some central device, now if Sally's electrical energy comes in at the same time as Bob's electrical energy comes in on this device, what if we made this device in such a way that that was okay? That this device could actually store these electrical energy. It could keep them separate, store them in separate places so they didn't run into each other. Now we could have a lot more people with separate cables connected to this device. And that was the next evolution of networking. That's where these things called switches and bridges came into play. So you might hear that term, switch or a bridge. So switch or bridge, that's what it did. It allowed every device to have its own separate, unique cable. And even if a couple devices were to talk at the exact same time, it was okay. Because when Sally's energy, we'll just say Sally's information now, the switch would get it on this interface right here, and it would store it. It would store it in what's called memory. Memory, which is a component of computers that stores this electrical energy so it doesn't just fade away. And when this person's electrical energy came in and it hit this port right here, even if it hit at the exact same time as Sally, let's say Sue's information came in, once again, memory was used in this switch or bridge so the 2 electrical signals would not touch each other. They'd be stored in separate sections of memory. Okay, so that was the first evolution of networking. Next evolution. So it used to be, way back in the dark ages of the 70s and 1980s and even the very early 1990s, that you had a network like this for your data. So all of your emails and web browsing and stuff, that went across these cables here and terminated on this switch. But you had a completely separate network in your company for something else, which was your voice, your telephone. So you had a telephone network, and the telephone network and the telephones connected to it was its own separate network, its own separate wires, managed by a completely different staff of individuals than your computer network. And then somebody had the bright idea of, hey, why do we have two separate networks? Why don't we develop these new kinds of phones that can actually connect to this network right here? If we could have our phones connect to our data network like this, then we could have one network that was carrying our voice traffic and our information, our data, our emails, our web browsing. And so that was the next evolution of computer networking, where phones were now able to connect to the network. And by the way, if you ever see the term IP telephony, or you see the term VoIP, which stands for voice over IP, that's what this is talking about. That's talking about this technology of taking your phones and connecting them to your data network and having one network support both. All right, so let's move on with the evolution now of networking. So now we got this network, we've got these series of cables, all individual cables going to a phone, going to a PC, going to a laptop, all terminating this one central networking device called a switch. Then if we increase this, then some people said, well, here's the problem with this existing network. If Bob over here, who works in Department A, needs to take his computer and walk over here to Department B, and he wants to connect to this network. So let's say this is Bob right there, real happy guy, and he's going to connect his laptop or his computer to this network. That would mean that Bob would have to disconnect from that first network cable, and while he's disconnected, no emails, no web browsing, no instant messaging, he is disconnected from the network. He'd have to walk his computer over to Department B and connect his computer to a cable in that department. Well, some people said, you know what? I like being connected all the time. I think it'd be kind of nice if I could do my networking, if I could do my email, my instant messaging, my web browsing as I'm walking down the hallway, as I'm going up and down the elevator, as I'm sitting out by the pool. You know, I'd like to be able to do that. I don't want to always have to be connected to a wire. And that's where networking evolved into what's called Wi-Fi. Now, Wi-Fi, some people think Wi-Fi stands for something. That's an acronym. No, it's not. It's just Wi-Fi. But Wi-Fi is the same as wireless networking. We're now, instead of using a cable to transmit our electrical energy, we're actually using the air. Just like radio signals go across the air, like the radio in your car, right? So it's the same concept. So we now invented Wi-Fi networking. And so now Bob's or Sam's computer still had to have networking software, still had to have some sort of adapter or connector to the network, but now that adapter or connector had a little antenna in it and used that antenna to radiate electrical energy into the air. And then the device that picked up that electrical energy was another networking device called an access point. I'll talk about that more coming up, a wireless or a Wi-Fi access point. And then that access point would then convert that back into regular electrical energy and put it back onto our wired network. Okay. So, and we'll talk more about these components as we go along here. Now, when networks were originally invented and you put networking software on a device, that device recognized, okay, I'm connected to something, let's just say a cable, and if I put electrical energy on this cable, that electrical energy can go to multiple destinations, which means, just like in human society, right? If you are in a room with a lot of people and you start saying, and you start talking, well, you're probably going to talk to one person, right? So what do you have to do? You have to preface your talking with, hey, Bob, which means Bob has to have a name. If you just start saying, Yeah, I looked at the stock prices the other day and blah, blah, blah. Everybody in that room is going to say, are you talking to me? Are you talking to me? Are you talking to me? So everybody in the network has to have a unique name. Same thing here in this type of networking. Networking software originally was written that a device, let's just say a PC, had a networking name. We actually call that an address, a networking address. So in the very early days of networking, if my computer was connected to the network, my computer would somehow have to discover the names of all the other devices connected to that cable, connected to that wire, so that when I want to transmit information, I could say, Sue, this is for you. Sally, this is for you. Bob, this is for you. Now, the names actually weren't Sue, Sally, and Bob. They were actually represented as numbers, as digits, but you get the idea. Once again, that was fine if I had a fairly small network, right? My laptop, my PC, my computer, it could keep track pretty well of, 10, 15, 20, 30 names, 30 networking identifiers. But if a network grew to hundreds or thousands of devices, it just wasn't really very scalable to have every device on that network know the unique name of every other device on the network. It just didn't work very well. So some very bright scientists, some very bright physicists, they got the idea. They said, hey, why don't we do this? Once again, let's drop back into human society, okay? So in human society, we have our geography sort of divided into sections, right? We have our country divided into states, states divided into counties, divided into cities, and then within the cities you have individual addresses, street addresses. And they said, why don't we create our networks, our data networks and our voice networks sort of like that? Where we say, okay, everybody in Department A, your devices are going to have a networking name, but here's what we're going to do. In Department A, now I'm just going to do an analogy here, not the way real networking works. Let's say the Department A, your names consist of 4 characters. Everybody's device, everybody here has a name consisting of 4 characters. 4 characters. But here's what we're going to do. We're going to make these networking names a little bit more logical, a little bit more meaningful. In other words, Department A, we'll say that all of your names start with A. Department B, all of your names begin with B, and your Wi-Fi users will have you start with W. Now, Bob over here, he can have the name of A123. Sally over here can have the name of A456. Okay? Over here, Sam, he can have B123. Susan can have B777. Right? John down here can have W555. So now the idea was, okay, we're going to subdivide our network into groups. And Bob, so here's Bob right there, our good friend Bob, our good faithful employee Bob. Actually, I haven't been sharing that, so there you go. All right. So everybody in the A group here has a name beginning with A, everybody in the B group with B, and so on. Okay, and here's Bob, who's A123. Now Bob generates some information, some data. He says, okay, I need this data to go to the computer with the name of A456. Well, Bob knows, hey, A? That must be in the same department as me because my name starts with A. So Bob says, okay, I can create my data. When I put my data in this wire, I will say that it's coming from me, A123, and it's going to A456. And because A456 is in the same department as me, if I just put this data on the wire, I can be assured that A456 will get it. As a matter of fact, this networking device right here, this switch that we were talking about, of all the devices that are physically connected to it via wires, it stores those names. This switch knows that on this particular cable right here is A456. On this particular cable right here is B777. It knows that. Okay? Now, here's where the tricky part came in. Once again, we don't want Bob's computer to have to know thousands and thousands and thousands of names. The only names that Bob's computer should really have to know are names within his own department, names that begin with A. Now, if Bob, let's say, had to send some information to B777, now Bob would say, okay, what do I know? I know I'm in the A group because my name begins with A. I know who I'm trying to send to is someone who's actually not in my group because their name starts with something else. It starts with a B. So now Bob would say, all right, I can't assume that this person I'm trying to talk to that starts with a B is on the same cable as me because it's not in the same department. So now we had to have a new type of networking device, something that would go right here. Something that could say, all right, I have an interface, I have a cable, and everybody on this cable has a name of A something. I have another cable, everybody connected to this cable has a name beginning with B something. I have another cable, everybody connected on this cable has a name beginning with W something. And the purpose of this device would be to say, hey, all you people in the A group, if you ever need to send any information to something that starts with something other than A, send it to me. I will know where all the other departments live. You don't have to know where they live. Send your information to me and I will get it going to where it needs to go. And so that was our next networking device that was developed, which is called a router. So a router knows of where all the different departments are, where all the different groups are. So when information comes into it, the router can say, oh, I can look up that in a the information comes in, it says, oh, it's going to X555. And the router has a special table, a special memory, and says, okay, let me look in there. Oh, according to my table here, anything that comes into me going to X anything goes out this cable right here. There, I'll send it out. If something comes into me, it's going to G something, G anything. My database, my table says, oh, I need to send anything going to G out this table, out this interface right here. And so that's what we call routing. Routing is this idea of taking our big network and subdividing it into sections, and then the router's in charge of knowing where each section is, and of all the cables connected to that router, which cable leads to each different section, each different department, each different part of the network. Okay, so let's keep evolving here. So things were going along fine. Now, back in the early days, each department would also probably have a special, really big computer, not necessarily big physically, but big in the standpoint of it was really fast, it could store tons and tons of information, and this is something that we called a server. So for example, this server might store all the emails that Department A need to have. And there might be a server on this cable here, which was another server for Department B. This maybe has all the web pages, the websites that Department B needs to get to. So once again, in the early days of networking, and even today in some networks, you have servers, which are these computers with a lot of information, a lot of processing power, really fast. They can handle a lot of stuff. You have a server over here that is storing some information, a server over there that's storing some information. Well, here's the problem. Originally, people thought, oh, you know, I'm in the advertising department of my company. So the advertising department has a server, and that stores all of our pictures and our images and our advertising logos and stuff. And we should keep that right here. So advertising is in this corner of the building. So our server should be close to us because after all, we own it, we maintain it, everything on there is put on there by us. But the problem is, look at it from the standpoint of the networking administrator, the person who put this network together and whose duty or responsibility it is to fix the network if anything goes wrong. Now imagine this networking administrator right now, imagine a big skyscraper that's like 30 stories tall, all right, with just thousands of people working in it. One monstrous giant network connects everything together, and there's just tons of different departments in this huge skyscraper. Now here's this networking administrator working on the first floor. He gets a call, or she gets a call. Hello? Yeah, hey, this is Tom. I can't get to my server. I can't get to my emails. Okay, now what does the networking administrator have to do? Number one, has to figure out, okay, what department do you work with? Oh, I work with payroll. Okay, now he's got to bring up some map of the building and say, oh, okay, payroll. Yeah, you're on the 20th floor and you're in this far right quadrant, this far right corner of the floor. Okay, now, you see, you said it's your email you can't get to? Yeah, it's my email. Okay, let's see here. Looking at my paper here, on the 20th floor in the far right quadrant, if I go to cube number 7, that's where the server is. So now the network administrator would have to trudge up the elevator, go up to the 20th floor, find that server, and try to work on it. Now imagine that's happening all day long with servers going down here and there and there and there. So some people had the idea, hey, why don't we take all these servers, which are scattered throughout our building, and put them all in one place? Let's put them all in one room, a very secure room that's locked tight. Nobody can get into it unless they have authorization to get into it. It's got a lot of air conditioning so it doesn't get overheated. And let's put all of our servers right there. That way, with them being in one central place, if anybody needs to upgrade or change their server, they know where to go. They go to that room. If anybody needs to do any troubleshooting relating to the server, they know where to go. Right to that room. So that is what we call a data center. So for example, here's our data center right here. We have tons, and you can't really tell by the size of these pictures, but each one of these things, so for example, this right here, this one thing right here, that is what we call a cage or a cabinet. That could well be 6 or 7 feet tall, taller than an average human being, and inside there could be dozens of these big, powerful computers called servers. So in this one cabinet right here, we could have servers from like 10 or 15 different departments, all in one place. Now, if you have a really large company, a really large network, you'd have something that looks like this, just tons and tons and tons of servers. But they're all located in one room, which is called our data center. Well, our data center also has to connect to the network. So there's special networking technologies used so that all these servers can connect up to the network and we can get to them whenever we want. We can get to them quickly, reliably. So there's that. And then, of course, the last component to our network is what I've drawn here so far. This is all great if all we want to do is exchange information within our company from one employee to another or from an employee to one of these servers here. But most likely, these people probably want to get out, right? They want to get out of their company. They want to get onto the internet. They want to do Google, they want to do CNN, they want to go to INE.com and watch all sorts of fabulous videos. So we also need a component of our network that connects to the internet. And so we have to call up a special company called an internet service provider. You probably know this by another name, like Time Warner Cable, Spectrum, AT&T, Charter Communications. These are all examples of companies that are called internet service providers because what do? They provide you service to the internet. They give you connection to the internet. And of course, you have to pay them monthly to do that. So that's sort of like our common computer network right there. I've gone through a lot of stuff at this point. So let me just take a break here and see what questions you have, if there are any unanswered questions I can help you with. All right, I'm just going to scroll to the top here and see if there's any unanswered questions. And by the way, I see some of you guys have been answering other people's questions. Awesome, great. There's a lot of people watching who already have a lot of experience, so feel free to answer somebody else's question if you know the answer already. Let's see here. Yep, AP equals access point, that's right. Yeah, I haven't really talked about DNS. I'm trying to right now sort of stay away from the technical terms of what's going on in here, but absolutely, if you know what DNS is, then you're right. That would need to be a component of this. So thank you, Mr. Khalid. Okay. I don't see a lot of unanswered questions at this point. But Muda Theater, you ask a good question. How to access private devices, like an IP camera connected to laptop 1 from laptop 2, where laptop 1 and laptop 2 are connected to the same router. Well, it doesn't really matter if they're connected to the same router or if they're across the ocean from each other. It always comes down to device number 1, which is, for example, laptop number 1. If it wants to connect to the IP camera of laptop number 2, it needs to know what the name is of that. In other words, what the computer name is, or in technical terms, what is the IP address? Remember how I said that every device has an address on the network? And I was using the examples of like A123, B777. Well, in reality, those addresses are numbers, and we call them IP addresses. So if one computing device wants to contact another, it has to know what the IP address is, what the name is of that second device it's trying to reach out to. And typically, a protocol called DNS is used for that. DNS, so when we as human beings get on the network, most of what we do is using human readable stuff. For example, when you bring up your web browser, you don't type in, 77.5.32.1. You type in something that's meaningful to you, like google.com or ine.com. You're typing in a human readable name. Well, but your computer needs to know what the number is, the numeric name of google.com in order to get to google.com. So when you type in, for example, in your browser, in your website, google.com, there's a process that happens in the background. You don't even see it. This is called the domain name service. That's what DNS stands for. Basically, your computer sends out a special message to a server it already knows about and says, hey, I need to get to google.com, but I really need to know what the actual numerical name is, the number, the IP address. Can you tell me? And then the DNS server will send a message back saying, yes, google.com is 8.5.32.100 or whatever. And now you can actually send your data to that IP address. So whether you're trying to get to a public or a private device, you need to know what the IP address is of that device. And usually DNS will help your computer figure that out. All right, so let's go ahead and keep going here. So I want to go through now some common vocabulary that you'll see once you start getting into the world of networking, or just read something about networking, some terms you need to know. So one term is LAN versus WAN. So a LAN stands for a local area network. When we think of local area networks, we usually think of networks that are fairly small. In other words, they don't go vast distances. A LAN could be as small as, two computers sitting on the same desktop, sitting on the same table with a wire between them. That is a local area network. Or it could be as large as one computer talking to another computer in the same giant company, but that second computer is talking to is a quarter of a mile away down the street. Some huge campus of like 15 or 20 buildings interconnected together. That's also a LAN. The characteristics of a local area network are usually such that, number one, all the pieces of the network, all the wires, everything that's used to put that network together is owned by the company. They bought all that wire, they laid all the wire down, all the networking devices, they connected them together. They are in complete control of that network. That is a local area network. And that's why typically it doesn't span very large as far as distance is concerned. Maybe up to about a quarter of a mile, and that's about it. LAN technologies, they only go about that far. A WAN is just the opposite. A WAN is a wide area network. So for example, when you sit on your computer at home and you bring up your web browser like Internet Explorer or Firefox or Chrome, whatever, and then you type in ine.com. Okay, so what's actually happening under the hood? Well, the actual web server, the server that has the ine.com website, has the pages and the images and the text and everything, that doesn't live on your LAN, right? That doesn't live in your house. That web server is hundreds, maybe even thousands of miles away from where you are. So how are you getting to that? Well, the way you're getting to that is leading out of your house, there's some cables, probably telephone cables, maybe underground buried cables or some sort of cabling. Did you lay down that cable? Did you pay for it? Did you buy it? Did you install it? No, you didn't. Your internet service provider put that down. Furthermore, you might be going across thousands of miles of cable. And as you're going across cable to get to that website, you're going through all kinds of networking devices in the middle that you don't even know about. Once again, you don't control all those devices. You didn't select them. You didn't make them work. You're not in charge of troubleshooting them. So that network that you're going across, that's going vast distances, that is called a wide area network. So a wide area network is a network that spans vast distance, that some other company, like an internet service provider, they put it down, they're in charge of monitoring it, they're in charge of troubleshooting it, and to use that network, you can use it, but you have to pay them. You have to pay them for the privilege of using that huge, long network that they created. That's called a wide area network. The term of node or host. So what's this? These are basically two terms for the exact same thing. Basically, any networking device that connects to the networking media. Let's just say cables, for example. Let's forget about Wi-Fi and fiber optic for a moment. Let's just assume that all of our networks are made of copper cabling, okay? Any device that connects to that copper cable, whether it be a laptop, a PC, a huge mainframe, or some networking device like a router or a switch, those are all considered nodes. A node is an individual device. It's connecting to the network. Now, a host is similar to a node. For example, a router or a switch and a laptop. All three of those are nodes. But the laptop, in addition to being a node, we could also use the word host for that laptop. Well, what's the difference? The difference is really you have to envision the actual information that's being sent on the network. A host defines the point at which that information started or the point at which the information ends or is being received. So for example, a PC that's sending information to a server somewhere, those two devices are hosts. The PC is creating the information, putting it on the wire, so it started here with the PC. He is a host. He's also a node. That information is traveling through lots of other nodes like routers and switches and other networking devices. Each point on that wire is a node. And then it terminates at another node, also called a host, which is the server. And we call that as a host because it's terminating that information. That information goes no further than that device. So the things that most people think about as connecting to a network, your tablet, your smartphone, your laptop, your PC, we would call those hosts. I just want you to be aware they are also technically nodes because a node is anything that connects to a network. And then these terms local versus remote resources. Let's use your laptop or your PC again as an example. So your laptop has local resources. You have a hard drive, right? So whenever you create documents in your laptop, or you're storing photographs that you downloaded, those are stored in your hard drive. Or you might have a disk drive that's got a DVD in it, okay? So those are all local resources. So even if you're not connected to a network at all, you can still access that stuff because it's built within your laptop. A remote resource is something that you can only reach, you can only get to if you have access to a network. So for example, when you check your Gmail, okay, let's assume you have a Gmail account like I'm sure many of you people do. So when you go into your email and you check Gmail, what's actually happening? Well, those emails are not stored on your computer. You know, if your computer was not connected to the network, you couldn't do Gmail. You couldn't bring up anything. Why is that? Well, because there's some server somewhere. Remember, a server is nothing more than another computer, but it's super powerful, super fast. It can store a lot of information, right? So there's a server somewhere that's owned by Google that's storing all of those emails. So you have to connect to a network to get to that server. So that server is an example of what we call a remote resource. It's something you want to get to, something you want to utilize, but you can only get to it via the network. And then, of course, the internet. What is the internet? The internet really is just a collection of networks that can all reach each other. They're all interconnected. So, for example, let's say that you have a small company, maybe 20 employees, in a small building somewhere, and you've got a network in that building. Now, on that network, you've got a bunch of PCs and laptops and phones connected. You also have some servers that have some internal websites on them. So the employees of your network can get to that server to find out when their next payroll date is, what their PTO or vacation balance is, how much their salary currently is, the schedule of their employee schedule. But that network right now is not connected to anything else. No cables leading outside of the building. It's all a self-contained network. Okay. Now, if we take that network and we attach a cable to it that goes to an internet service provider, now that very same network has become part of the internet. It's become a part of the internet. And so, which means that you are just part of billions and billions of other networks, all connected to internet service providers. They're all connecting everything together. That's basically what the internet is. So hopefully at this point, I think it's fairly clear as to why we need computer networks. Networks basically just allow us to share things. They allow us to be more efficient, more productive. So for example, we can share files, right? Dropbox is an example of that. I can put a file on Dropbox like an image, like a photograph, or maybe a song, and then you can download that file, right? That allows us to share things. If we didn't have the network, we wouldn't be able to do that. It allows us to share programs. So for example, Google Calendar is an example of that, right? When you bring up, once again, your browser and you go to Google Calendar, you are actually utilizing a program or a software application. It's not being run on your computer. It's being hosted by Google somewhere. Somewhere Google has a server that has the Google Calendar program in it, and by using the network, you're accessing that program and it's sending back to you and it's displaying on your monitor what your calendar looks like. Okay? Or we can share resources. Back in the old days, if you wanted to print something, you had to have a printer physically connected to the back of your computer. Your computer had a special connection called a printer port. You had a special cable that would connect to that, and that would connect to your printer. So if you had a company of like 20 employees, and all those employees needed to print stuff frequently, every employee had to have a printer. Well, nowadays, you don't have to do that. Nowadays, they sell special printers that connect to the network. So you can have one printer sitting in the office, and all the people, by using the network, can get to that printer and print to it. So that's considered a resource. That printer is a resource that's being shared among multiple devices. And there's lots of other examples of resources like disk drives and cameras and things like that that can all be shared across the network. All right, so that brings us to the end of this particular section. Let me just go back to the Q&A here real quick. What questions do you guys have for me? And Mr. Fail Standstill, the question you're asking is sort of off topic right now, but hey, since I'm not getting a lot of questions, I can answer yours. So you asked me, please advise, what certification track is covering Q&Q topic? So most likely you would find that in the service provider certification track. That would be a service provider technology. And so like the CCNA or CCNP service provider would cover that. If you're going in the routing and switching track, by the time you get up to the CCIE, you will need to know Q&Q, but you don't need to know anything about Q&Q at the CCNA or the CCNP level for the routing and switching track. But for the service provider track, I'm pretty sure that at the NA level, certainly the NP level, you would need to know Q&Q. Elias, you're asking for designing networks, which course would be good? So Cisco is like the premier networking company. If you've never heard of Cisco before, I'm not talking about the Cisco that starts with SYS. No, I'm talking about CISCO. That's the Cisco we're talking about here. So Cisco is like the behemoth, the monster of networking companies, right? That's what they do. And Cisco offers these tests or these certifications you can take, and if you pass their tests, then it proves you know something, right? And the tests start out at sort of a lower level, and then they go all the way up, and they get harder and harder and harder as you take them. Well, what you're talking about, networking design, is Cisco has some tests, and I'll go ahead and put this on here. If you see their certifications that begin with CC, now that stands for Cisco Certified, CCD something. This stands for design. So if you want to learn about networking design, you would start with the CCDA, which is the Cisco Certified Design Associate. Then the next ones you would take would be the CCDP, which is several tests. And then finally, you'd finally have the CCDE, so Design Professional and Design Expert. Okay. So those are the exams you would take. Those are the courses of study you would have if you're interested in network design. And I'm sure there are other vendors' tests that also do the same type of thing. Okay. Don't see any other questions coming in, so let's do one more brief section, and then we'll take a break. We'll take like a 10-minute break just so I can get some water here, and we can move on. So in this section, I'm going to talk a little bit more detail about the components of computer networks. Some of this stuff I've already covered in the previous section, so this should go fairly quickly, but there are some new elements here I want to introduce right now. So I've already talked about these terms here, servers and clients. I didn't really use the term client, but I have talked about servers. So I mentioned that a server is just a big, powerful computer that has lots of memory, lots of processing power. It can store tons of information. People can access that server across the network and retrieve information from it. And a server is powerful enough that it can handle sometimes thousands or tens of thousands of people all accessing it at the exact same time, and it can handle that. That's an example of a server. And a client is the device that's accessing that server. So for example, your typical clients would be things like we see here, like your laptop or PC, like your tablet, like your smartphone. Okay? Those would be all examples of clients. And those clients would all be accessing the information that's stored on these servers. And you'd have to make use of the network, all the network components to get to it. So another term, so when we take a look at this stuff right here, so this is the network, right? This is allowing us to get from the client to the server. Another term that you'll see to describe all these things, the cabling and then the network devices that are attached to it, is called the network infrastructure. Hopefully I spelled that right. Infrastructure, yes. Okay, so if you ever hear that term, oh, I'm troubleshooting the network infrastructure, or I'm building a network infrastructure, that's the fancy way of saying, hey, I'm troubleshooting or building all the cabling and all the routers and switches and everything that's making the network work. That's the network infrastructure. We've already talked about local and remote resources. So I don't think there's anything new on here. Once again, just to reemphasize, a local resource means something that you physically can touch that's right in front of you, that you can utilize even if you're not connected to a network at all. That's a local resource. A remote resource or a networked resource is something that clearly you can only access if you are connected to the network. Okay, so I mentioned in the previous section, I said that there's sort of three common elements that are required to make even the smallest of networks work. I said devices had to have network software. Now, most operating systems these days come pre-installed with networking software. So when you buy, for example, a laptop running Windows, Microsoft Windows, there's an element, there's a component of Microsoft Windows that understands networking. It's built in there. You don't have to download it, install it. It knows what networking is. When you're using your iPad, right, the iOS operating system has a component or an element inside of it that understands networking. So just be aware that the software you're running has an element of networking already built in there. Otherwise, you could connect to cables all day long and your device wouldn't even recognize those cables. So you have the software. I said you had the network media, like, for example, the cables, but I said your device had to have some component, some adapter that connected to that cable, that allowed that cable to plug into you. And that's what we call a network interface card, or a NIC. So you might hear that term a lot. So if you're ever doing network troubleshooting and let's say you call up someone and you say, hey, I can't connect to the internet. They might say, well, is your NIC connected? What they're really asking you is they're saying, hey, do you have a cable plugged into your laptop, plugged into your PC? Where it plugs in, that little hole in the side, that is your network interface card. Now, a lot of times, you can only visually see, if you hold up your laptop and you move around, or your PC and you look for your network interface card, most of the time, the only part of it you can see is this tiny little part right here, right? The exterior part where the cable plugs into. But the entire NIC is this whole thing right here. Behind that cable, there's all these electronics and circuitry and everything that know how to deal with that electrical energy, that know the rules and protocols for, hey, when do I talk? When do I have to be quiet? How long can I talk? When do I need to stop talking? Is this information coming in for me, or should I ignore it? All those answers are provided by this circuitry right here. But that's usually deep in the guts of your laptop or your tablet, and you can't see that. One other thing I just want to point out here, some other common terms you might see. So there are lots of different kinds of networking cables. Okay, so if we just focus on cables right now, there's not just one. There's several different kinds. Now, the most popular form of networking cable is typically called Ethernet cable. And it looks like this. Technically, what is Ethernet? That term, Ethernet. So you know how I mentioned that there are rules to networking? Well, Ethernet is one set of rules. If I'm using Ethernet to connect to my network, that means I'm using a set of rules that tell me when I can talk, when I can't talk, when I am sending information on the wire, when I need to stop and give somebody else a chance. When information's coming on the wire and I'm receiving it, how do I know if it's for me or not? Ethernet is a protocol or a set of rules that does all that, that answers all those questions. Part of Ethernet, also, if you actually read the document, Ethernet's like hundreds of pages long if you actually to read all those rules in document form. Part of that document would also say what the cable's supposed to look like this right here. It would say the cable's supposed to be so thick and have so many wires in it and stuff like that. Ethernet specifies that. As a matter of fact, as you start getting into networking, you start realizing that everything has a specification. The little plastic pin on the little plastic connector on the end of your cable, there's a specification for that. How big that should be, how thick it should be, where the tab should be. There's specification for what the rubber coating on the end of the cable, that everything has a document and a specification. So another one is this, RJ45. What is that? Well, there are specifications not only for the cable, how thick it should be and everything, but there's also specifications for the connectors on the cable. So for example, this type of connector that you see right here, that's a very common connector. Ethernet cables that run the Ethernet protocol typically have that type of a connector, and that connector is called RJ45. RJ stands for registered jack 45, or registered jack number 45. So the registered jack 45 specification says that it should look like this. And this is the connector, this is the receptacle that an RJ45 connector would plug into. And that's typically what you'll find on the side of your laptop or the side of your PC. Your network interface card will have an RJ45 jack. If there's nothing plugged into that, that means you're not plugged into the network. At least you're not plugged into a wired network. You might also have another network interface card, and I'll show you that in just a moment, that's actually connected to a wireless network. You can see here, there's even another type of registered jack. Looks very similar to RJ45. This is called an RJ11 jack. This is typically used to plug your phones into. So in the old days when you had a regular telephone, it would plug into an RJ11 receptacle. Now I mentioned that this is the most popular form of networking cable, is Ethernet cable, and RJ45 is the most popular type of connector. It's not the only connector that Ethernet can work with, but it's the most popular connector that Ethernet works with. But there are other types of cables as well. For example, you probably have seen this one, what we call a coaxial cable. So if you've ever had cable TV in your home or apartment or condo or something, you have seen one of these cables. This is what connects up to your cable box. This is called coaxial cable. So it's a different type of cable. As such, it has a different type of connector, right? That is not RJ45. Okay, that's something actually called an SMA connector. You'd never have to know that, but just want you to know there's actually another standard called an SMA standard that specifies what that connector looks like. So whenever you see that connector, you should say, okay, that goes to a special type of cable called coaxial cable. Still got copper inside of it, still transmits electrical energy back and forth, but the rules and the protocols for how you send electrical energy on that cable are different than the rules and protocols used in Ethernet. Now what about Wi-Fi? We've talked about that. Well, we know that Wi-Fi goes over the airwaves, but we still have to have something that, because your laptop, your PC is dealing in electrical energy, right? Whenever you press a key on your keyboard, like you press the H or you press an A, there's some electrical signal that's generated from that. And the electrical signal, the electrical energy that's produced when you press the A is different than when you press the 1 or you press the 7. So inside the guts of your laptop, all the data that you're creating is all electricity. It's all converted into electricity. Now for connecting to a wired network, that electricity is then converted into another kind of electrical energy that's suitable for the wired network. But what about when we're dealing with Wi-Fi? Well, in Wi-Fi, that electrical energy has to be converted into radio energy, right? What we call radio frequencies, or what's called RF, which is energy that's radiated into the air, that's not designed to go across cables. And once again, we have to have a network interface card, an adapter that takes that electrical energy from inside the guts of our computer and converts it and radiates it out into the air. And so that's what we call a Wi-Fi NIC card. So a Wi-Fi NIC card has to have an antenna that's used to radiate the electrical energy into the air and to listen to see if any electrical or radio frequency is coming out of the air that it can convert back into electrical energy. So some Wi-Fi NICs, you can actually see the antenna, like this one right here. Most Wi-Fi NICs these days that go into your laptops or your tablets or your smartphone, they have an antenna, but you can't see it because that antenna is built into the guts of the device. Like for example, right here, this is like what an iPad looks like. If you took an iPad and you opened it up, you cracked open the back of it, These are the guts of it. And for example, this sort of long thing right there, that's an antenna inside your iPad. That's part of your network interface card to get you access to the Wi-Fi. If you don't have an antenna, just like driving in a car, right? If you don't have an antenna on your car, you're not going to pick up any radio channels, any radio signals. Same thing here. Wi-Fi relies on having at least one antenna, frequently more than one, to be able to radiate the radio frequencies into the air and to receive the radio frequencies from the air. So as far as components are concerned, you've got your cable, you've got your network interface card, and you have your software. Now, if our networks start getting bigger, we can't just connect two PCs together anymore, right? Now we start having to have those devices I talked about earlier, which are called switches or bridges. So the idea here is that, okay, let's give every single device its own cable, and each one of these things right here, let me make this a little bit bigger so you can see it. These are individual RJ45 connectors, and you can see there are lots of them. Now, depending on the switch you get, it might be a small switch like this one right here. Could have up to, it looks like 8 laptops or PCs connected to it, so we call this an 8-port switch. Each port has a cable connected to it. Or you can get some monstrous switch like this one right here that has hundreds and hundreds of ports on it. And clearly the price of one of these guys would be a lot more expensive than the price of one of these guys right here. But these are all switches. Now I mentioned that switches were great if, remember when I was talking about networking addressing? And I said back in the early days, everybody was connected to one cable, everybody had a network address, and your device had to know the network address of every other device connected to that cable. So now we migrate to switches, where every PC, every laptop has its own unique cable connecting to one of these switches. Well, once again, if your network is fairly small and your desire is, hey, I want every device to know of every other device, then a switch is fine. Switches actually do this. Switches learn the network address of every single host, every single node connected to that switch. They have a table, they have a piece of memory that knows the address of every single device. And that table can sometimes store hundreds or even thousands of addresses. But a lot of times we don't want our networks to look like that, right? We want to subdivide our networks. We might want to say, well, I'd rather have payroll have a unique set of addresses that are different than marketing. And for security reasons, I don't want all of payroll's devices to know about all of marketing's devices. I want to have a device in the middle that knows about the two departments, and on that device in the middle, I want to be able to separate them so that some traffic is allowed back and forth, but other traffic is not. I want to control that. Can't really do that with switches. Well, you can, but it gets very, very complicated. So the device that allows you to do that, we talked about, is what's called a router. Now another thing, let me go back to switches here for just a moment. Switches are also good if everything connected to the network is using the exact same cable, the exact same protocol. For example, I talked about Ethernet as a protocol, Ethernet as a set of rules about how you access and deal with the network. Well, if all of my devices were running Ethernet, yeah, I could all connect them to the switch. But what if that's not the case? What if I have some devices that are using that coaxial cable we just talked about? What if I have other devices that are using Ethernet? What if I have other devices that are using something completely different? Switches don't work so well with that. This is another use case for router. So router can allow you to connect to different types of cables. So electrical energy coming in, for example, over an Ethernet cable can be translated into light energy across a fiber optic cable, and a router could do that. Routers also allow you to have better security by dividing your networks into zones or sections. This section over here has this particular address that the router knows where it is. This section of the network over here has a different type of address. So router is kind of like the post office. Think about the post office. So, you know, I live in the Raleigh, North Carolina area, all right? Now, let's say a post office in my neighborhood, I send them a letter, I give them a letter, and the letter says, going to grandma in Boston, Massachusetts at 555 First Street. Okay, I'm going to write this right here so I don't forget. Grandma, 555 First Street in Boston, Massachusetts. Okay, now the Raleigh post office, the Raleigh, North Carolina post office is getting this. Do you think that the employees in the Raleigh office actually know how to take that letter and physically walk it all the way to Boston? And they know once they get to Boston exactly where First Street is and exactly where the 555 First Street is? No, they don't know that. But what do they know? They know, oh, well, if I put this letter on this airplane right here, this will get to Massachusetts. If I put this letter and put on this airplane right here, this will get to Texas. If I put on this train right here, this will go to Georgia. That's sort of like what a router does. When a router gets some data coming in and the data says, hey, I'm going to, so here comes some incoming data on this interface right here, and the destination of that data says it's 7.40.32.100. All right, so that is the actual name, the numeric name of some device connected to a network somewhere. Well, when that comes into the router might not know, so the router's got all sorts of cables here leading different places. When the router goes into its table, it's not like a switch. A switch would have to know this entire name, all those numbers and which cable led to that name. The router's more like a post office. The router says, well, I might not know exactly where that is, but I do know where 7 lives. I know that if I go out this cable right here, that will eventually get me to all addresses beginning with 7. So that's what the process of routing is. The router knows where the various different departments and organizations are based on their numbers, and it can route or transmit the packet, the information, out the correct cable based on just a partial match. It doesn't have to match the entire name. As long as it can match some of the name, it knows how to get that information where it's going. And then, of course, with Wi-Fi, we have a couple of components here we need to talk about, which is our Wi-Fi access points. So you typically see these in the walls or the ceilings. And so, once again, your laptop, your smartphone, your tablet has an antenna in it. You might not see that antenna, but it's in there. And that antenna is taking the electrical information that your laptop's creating and converting it into radio frequencies and radiating it into the air. And a few feet away, that's being picked up, that radio frequency is being picked up by one of these, an access point. So the access point also has antennas. You say, oh, wait a second, I don't see any antennas on this guy. Oh yeah, there's antennas in here too. Inside this, you just can't see them, but there's a lot of antennas in there. Gotta have antennas if you're gonna pick up radio frequencies. And then both of these guys will have a cable that comes out the back of it. A lot of times you won't see the cable. The cable might be in the ceiling tiles or going into the wall or something. And that cable will lead us back to, most likely, our good friend the switch. So radio frequencies are coming in. Radio frequencies. And this guy has to convert that into electrical energy and then put on the wire to go to the switch. That's the job of an access point, among other things. So that brings us to the end of that section. Let me see if there are any unanswered questions I can help you guys with. Oh, Matthias, you ask a good question. What's the best certification for network virtualization? Not product-oriented nor vendor-oriented. I'm not the best person to ask for that. My specialty is in routing and switching. For me, if I was interested in network virtualization, I want to learn more about that and get a certification in it, I would probably pursue something from VMware. From what I know and what I hear, VMware and their operating systems and their technologies are one of the top competitors for network virtualization. They offer their own certifications and tests, so I would probably go for one of theirs. I don't know if there is any such thing as a vendor-neutral network virtualization test because network virtualization is so dependent upon software. All right, somebody's asking, what is a default gateway? Good question. Let me explain what a default gateway is. So I will bring this up here to draw this. Okay, so here you have your laptop. Your laptop has some sort of network interface card built into it. You connect that network interface card to your cable. Okay. Or, let's say you've got another network interface card that has an antenna in it and you're doing Wi-Fi. And so your medium is Wi-Fi. Either way, so let's say Wi-Fi, that means then you're going to be connecting to an access point. Okay. Which also connects to a cable. So either way, your information is going to be put on a cable in very short order, either because you're directly connected to the cable or because the access point is taking your radio frequency and then putting it on the cable. All right. So a default gateway is another word for router. So you're going to have some sort of router also on your cable. And the idea behind a default gateway is that any other devices on this cable, for example, maybe you have a server connected to this cable. Maybe you have another laptop on this cable. Okay. Your laptop will know the network addresses. So each NIC card, every network interface card, has a network address. There's a unique number, a network address built into the NIC card. And so when my laptop, let's just say this is me right here, and let's say this is Bob's laptop right here, and he's got a network interface card as well. So when my laptop is sending information to somebody on the same wire as me, so when I put my electrical energy on the wire, if the intended recipient is someone who can read that electrical energy immediately, then that electrical energy, that information is going to the address of that person's NIC card. So for example, if I'm sending information to Bob, that electrical energy that's going on the wire like this, somewhere in there, it will have Bob's NIC's address. Okay, whatever the address is of Bob's NIC card. But most of the time, when you are putting information onto your network, it's not really meant, the destination, the ultimate place you're trying to get to, is not someone on the same wire as you. It's someone way out here, hundreds or thousands of miles away from you, who also has a NIC card, also connected to a cable, also connected to a router, but they're far away from you. Well, in this case, so when your laptop or PC creates information and it puts a destination address in there, first thing it does is it compares the destination address with its own address, with its own name. And by doing that comparison, it can tell, and I'm not going to get into the details of that now, but it can tell, is this destination I'm trying to reach on the same cable as me, or is it not? So if I'm trying to send information to this device way over here, something about the address I'm trying to reach will tell my laptop, oh, this is not on the same cable as me. So in that particular case, now when I put my electrical energy on the wire, the NIC card, let me just put this here. Let me just arrange this or erase this a little bit. All right, so now when I put on the wire, I actually need to send it to this guy's NIC card, my router. So this electrical information will have an address going to my router's NIC card. Now you might be thinking, well, wait a second. If it's going to the router's NIC card, doesn't that mean it stops there? Doesn't that mean you're talking to the router and that's where it goes? No, because when you put information on a network, when you put information on a wire, you're actually at the front of the information, there's two addresses you're sending it to. And this is where it gets a little bit complicated. If you ever watch any of my CCIE videos, I'll talk a little bit more about this. But your laptop, your smartphone, your tablet actually has two names it uses to get onto the network. One of the names is burned into the network interface card. That network interface card has a name that the manufacturer put on it. The other name that your laptop, let's just use laptops as an example, is a name that gives some indication as to where in the network you are. Like remember at the beginning of my presentation I said everybody in Department A had an address beginning with A something. Everybody in Department B had an address beginning with B something. Well, that address is not part of your network interface card. When you connect to Department A's network, you dynamically, all by itself, obtain or receive a second network address that's appropriate for that department that you're on, Department A's network. So how that relates to here with a default gateway is that this laptop here says, okay, if the ultimate destination where my information is going is not on my network, it's not part of my department, then what I need to do is that when I put my information on the wire, I need to address it going to the router's NIC card, my default gateway's NIC card, and the secondary address, the second address in that data will actually be the end recipient, like this server over here. So now when the router gets it, when he gets that electrical energy, at first, he thinks it's for him. Because the electrical energy is coming in, he says, oh, right here is the destination address. Oh, that's me. That's my network interface card. That's me. But then when he looks a little bit further into the electrical energy and sees that second address, he says, oh, this information is actually not for me. It's for somebody with some other name. And now the router does routing. He looks up into his routing table. He says, okay, of all the cables I've got, which cable will I further this information? So that's why we call it a default gateway. From the PC's perspective, the PC says, look, I don't have to know the address of every single network interface card in the world. There's billions and billions and trillions of network interface cards in the world. My laptop says, I don't have to know about those. Really, there's really only two network interface cards I need to know about. My own address, and I need to know about the address of my router's network interface card, because chances are that 90% or higher of all the information I put in this wire is not going to be meant for this wire. It's going to be meant for something thousands or hundreds or dozens of miles away from me. And the only way I can get to those places, because I don't know what their network interface cards are, I don't know what their names are, I got to send that stuff to my router, which is what's called a default gateway. Long answer for a very short question. So hopefully I didn't bore you with that. All right, let's see. All right, so I'm just going to answer another one or two questions. Now, keep in mind here that the aim of this particular show today is for people who have virtually no or absolutely no networking knowledge, just to introduce them to this concept of an introduction to networking. Now, a lot of you guys are asking really good questions, but their questions are far above the scope of our class today. And my concern is if I get into your questions about Cisco ICE and routing tables and stuff like that, that the people who are watching, who know nothing about networking and that's what they want to get out of this, they'll just phase out. They'll be all, I don't know what Keith's talking about now. He's answering questions that are Greek to me. There's no point in me listening anymore. So I'm really going to focus my answers just for the real basic stuff, okay? Like I said, if you ask a question that I don't have a chance to get to today, by all means, always post it on the IEOC or send it to me directly. But I really want to focus my answers on the real basic stuff because that is an introduction to networking. That's what our objective is today. Just wanted to put that out there. I didn't want you guys to think I was ignoring you. All right, I'll answer just a couple more questions and then we'll take a brief break. 133 major, you typed, if I type no IP routing, presumably on a router, will that make the router become a layer 2 switch? No, it will not. It will not. In order for something to be a switch, it has to have a MAC address table. It has to have switching functionality. Routers are not switches by default. You have to enter a lot of commands to get a router to act like a switch. That one command, no IP routing, will not be sufficient. Okay. What's the difference between iOS on layer 2 switches and layer 3 routers if I can type the same commands on both devices? The difference is in their functionality. First of all, they won't necessarily support the same commands. A lot of times routers will support iOS commands that are completely different than commands supported by switches and vice versa. Another thing is how they implement the command. For example, let me do this analogy, right? So back in the early days, the very early personal computers, everything was done on your CPU, on your central processing unit. The display of your monitor, all the sound that came out of your speakers, everything was controlled by the CPU, okay? That's sort of like a router. A router, his brain, his CPU, does pretty much everything. All the features that you configure, all the things that you do in iOS, his CPU is pretty much handling all that stuff. Now let's go back to PCs. Then PCs evolved, and people started saying, hey, we should create special circuit boards to offload the CPU of the PC to make things more efficient. For example, like a graphics adapter, right? When you buy a graphics adapter and a special circuit board and you put it in your PC, now a lot of the graphics functionality, what's being displayed on your monitor, your CPU doesn't have to do anything. Your graphics adapter is doing most of that. That's like a switch, okay? So a switch and a router, you can type in the same command sometimes and enable the exact same feature. But in a router, that feature is going to be implemented by the brain of the router, by the CPU. A lot of times on a switch will have special dedicated circuitry, special dedicated hardware to do that exact same thing, but a lot of times they do it much quicker and much more efficiently than a router would do it. Okay. All right, one other question from Siva. So you ask, what would be the best direction? Service provider, track, or the security track after completing a CCNP in routing and switching? Boy, that's really a subjective question. I'll tell you this. From working here at INE, I have some visibility into the popularity of our courses and that specifically the popularity of our boot camps. It seems to me that our security courses and our security boot camps are more popular, get sold quicker and fill up faster than our service provider, which leads me to believe that security is a more popular just topic in the world. And I've heard from other people too that if I was to compare security and service provider, I would probably go down the security track. So that probably has more job openings, more availability than going down the service provider track. All right, so with that, let's take a break. I'm going to take a 10-minute break right here just to get something to drink and to regroup here. And I will see you guys back in 10 minutes. All right? So I'll see you back then.
You know, I think that when I first started that there was, you know, I had a perception that I knew a lot about the core protocols. And now, you know, I realized I didn't when I first started. And this has really filled in those gaps. Just getting in there, labbing the stuff, seeing the problems, correcting the problems.
I've never seen anything out there like this. And I've been to multiple Cisco courses for my CCNP, CCNA. But this, you actually get to see the technology work. So it kind of helps stick it in your brain.
Our sessions are very interactive, always available to answer any questions during the session or offline.
He gives you the right mentality you need to approach any problem or troubleshoot or, you know, answer a question on a test.
It's helped me a lot, you know, even stuff that's not even for the CCIE, you know. I had the all access pass, just the knowledge that you get from them, you know, not only like, you know, this is how you configure it, but they actually show you in the video, this is how it works. And that's what you need. You can't just read a document and be like, well, this is the configuration. So hopefully it works, because sometimes it doesn't work.
I wish that I'd start off with material just like this, because I would have understood right off the bat what the theory is and what it's actually doing in the command line.
It's definitely more advanced. I think it's explained in a better way, better analogies. I think it's tougher, which is good. You know, I took one that was earlier and it was easier, you know what I mean? So it gave me this false confidence. And so now you're getting into this stuff and you see like, wow, this is a little bit more advanced. So, you know, I want to do some more of this stuff, and now I'm starting to feel way more comfortable.
A few of the weak spots that I had, I'm able to get over those things and understand those things better.
It's easy to study for a test and just study exactly what you need to know, but in this class we've gone kind of above and beyond, and he showed us things that can actually apply in real world and some things that may not be applicable to the exam, but are good things to know, especially when troubleshooting. And
I definitely recommend it. I've been recommending it. Just using the materials, now going to the camp, I'd recommend it all day long. It's a completely different learning experience.
The best way to become an expert is to learn from one. With INE, you will have access to the most experienced and esteemed IT and development experts in the world. Our content is expertly driven and solely designed to provide industry-best instruction that will make earning your certification or advancing your career easier than ever. INE's dedicated instructors have already trained thousands of experts. So what are you waiting for? Sign up today for an all-access pass for unlimited access to thousands of hours of content and our free live V-seminars. And be sure to download our mobile app for iOS and Android that gives you access to all of our training on the go. INE, experts at making you an expert.
Welcome back, everybody. Hope you enjoyed the break. Let's go ahead and get back into the last few topics of our course here. There were a couple questions that came in via the break. So let me just go ahead and take a moment to answer those, and then we'll move forward. So Siva, you asked a couple of good questions. You say you want to master one particular technology. Here are my options. So I guess you're giving me three: BGP, MPLS, and firewall. Which would I choose? Well, if it was me and I had to pick one of those three, I would pick firewalls. Looking through, every once in a while I look at job openings just because I want to see if there's some common keywords that are prevalent across a lot of job openings, and I frequently see probably at least 60 or 70% of all networking related job openings I see mention something about firewalls. So firewalls are absolutely mentioned far more often in job openings than BGP or MPLS. So I would pick that if I had to pick one of those three. And your second question is also a very good question. You say, I often forget networking concepts when I'm moving from one topic to another. Please give me some useful tips to remember. wow, you know, you and me and everybody else. That's a very common problem. And I don't know what to tell you. I struggle with that too. I think everybody does. If it's something you don't deal with on a frequent basis, you're prone to forget it. So my only advice to you would be, and this is what I say in a lot of my other classes too, especially like my CCNA kickoff series that I do every single month, I say flashcards, flashcards, flashcards. You should create flashcards for yourself as you're studying things and test yourself on the flashcards. And then when you move on to another topic, keep those old flashcards. And every once in a while, like once every couple of weeks maybe, refer back to those flashcards just to keep it fresh in your memory. You've got to do something to keep it in your memory, because if you're not working on those topics, well, you got to do something, and flashcards are a very good, quick, and easy way to do that. It's the only thing I can think of to answer that question, unfortunately. All right, and so let's go ahead and move forward here, and the next thing I want to talk about are some job roles and descriptions that you can get in the computer networking industry. So if the types of things I've been talking about interest you and you want to go deeper and you want to maybe get a job in this, what types of jobs exist? So let's talk about that. So first of all, the tasks that you will deal with fall into several different categories, okay? And a computer networking job role will require you to perform one or more of these duties. So let's talk about what each one of these are. So network analysis. A job that has a primary emphasis in network analysis means that you are brought into a company to, number one, before you even look at the network, you're going to interface with the human beings. And you're going to ask them questions like, why did you design your network? Are you happy with your existing network? If not, why not? How's the network currently supporting your needs? How is it not meeting your needs? How do you see your company's use of the network changing or growing in the future? So you're going to get a good picture of what their objectives were in the past, what they are now, and what they will be moving forward. Then you will shift your view to the existing network and you will analyze it in view of those objectives. You'll say, okay, now that I know what their past objectives were, I can see why they built the network this way. I can see why they implemented this feature and this feature and this feature. Now they're telling me that this is not very good. There's certain objectives they have currently that just aren't being met. They have certain unmet needs right now. So let me look at the network and see if I can figure out why that is. So you're basically analyzing the network, the current network, to see how does it meet their current needs and can I identify why they're dissatisfied with it right now, and then provide some recommendations for that. That's network analysis. Network design is very similar to network analysis, but network design is typically done on the front end before a network is even created. It starts the exact same way, talking to the customer, getting feedback like, what do you want your network to do? How do you see yourself using this network? What types of information and data will be using this network? How many devices do you anticipate connecting to the network? And then getting all that feedback and then constructing a network, coming up with a design document saying, okay, based on what you told me, I think you should have this many cables. Here's where I think they should go, behind this wall and up in this ceiling. I think you should have this many networking devices, and you design it. Now, it doesn't mean that you actually build it. That means at the end of the day, network design means you basically create a document. In that document, you say, this is how I think you should build out your network to meet your requirements. That's network design. Now, network implementation is the person who takes that document and actually makes it a reality. Somebody who lays down all the cable, who installs and configures the routers and switches and other networking devices, who puts the access points on the walls, who tests everything. That is network implementation. Network troubleshooting, I think that's pretty clear, right? There's a network in place and someone is not able to get from point A to point B, or something's really slow on the network and you have to troubleshoot. Where's the problem? How do you fix it? And network monitoring is very similar to network analysis, but network monitoring doesn't really involve talking to the customer and finding out what their objectives and needs and unmet needs are. Network monitoring means you're looking at an existing network and you're looking basically for red and green lights, right? Red light means some trigger or threshold has been exceeded and some part of the network is about to go down or is going down. If it has gone down, then you got to give it to the network troubleshooting folks to figure it out. But network monitoring, it's kind of like an air traffic control, right? In the airport. Air traffic control sees all the airplanes coming in and out. They're monitoring it, and they're just making sure they're trying to head off any problems before any problems occur. That's what network monitoring is, trying to head off problems before problems occur by monitoring and watching the network like a hawk. So when you get a job in computer networking, depending on what kind of company you work for, how big or how small it is, will determine how many of these things are rolled into your job. Some people do virtually all of these, right? Sometimes if you work at a small company, your job might be all this. You are like the one networking guy in your company and you got to do all 5 of these bullet points. Other times when you work for a really large company, like if you work for Cisco Systems or Google or Apple or Amazon, if you work for their own internal network, you could probably just specialize in just one of these bullet points right here. All right, so what are the titles of the job roles available in the world of computer networking? That's what we're going to talk about here. I'm going to talk about all of these. All right, let's start with network engineers and network architects. So a lot of times these job titles can be intermingled or intermixed. They can mean the same thing depending on who you're talking to. But generally speaking, a network architect is at the top of the food chain. So you don't immediately start out as a network architect. A network architect is like your long-term career goal. This is after you've gotten like several certifications, you've been working in the field of computer networking for at least 10 years, and you ultimately want to be a network architect. So as far as money is concerned, network architects make the most money, but it's something that's your long-term goal. Now, what do they actually do? Network architects are primarily into network design, right? So those are the people that will go into a company and, like I said, talk to the people, interface with them, find out what their needs are, find out what their objectives are, and design a document of like 50, 60, 70 pages with all sorts of graphs and images and bullet points recommending that a network be built in a particular way. So they are just like a building architect, right? So a building architect doesn't actually go out and lay the brick and mortar and hammer the nails. What does the building architect ultimately produce? A document that says, this is what the building should look like. These are the components of the building. This is how everything should fit together based on what you have told me. A network architect does the exact same thing. Now, and it says here, a network architect is typically hired as a consultant. So most companies don't have network architects on their staff as a permanent employee with paid vacation and health benefits and everything like that. You get paid a lot of money, but you have a certain contract of time, like 6 months or 9 months or something to come up with something. And during that amount of time, you'll get paid a lot of money, but you're still a contractor. You still got to pay your own benefits. You don't get any paid time off. So some people, they're fine with that. Other people don't like the risk involved in a job that doesn't have benefits. Now, a network engineer is like, okay, think of the concept of erecting a building, right? So the building architect finally comes up with the plans, and who does he or she hand the plans over to? Most likely a building contractor. So there will be some head contractor who will get those plans, and that head contractor will say, okay, I need to buy lumber from this particular company over here. I need to buy nails from this company over here. I need to make sure we have this many drills and this many saws and this many hammers ready to go. I need to hire my employees and I need to oversee them. Okay, you over there, you need to cut that to a certain length. So A network engineer is very similar to that. They implement what the network architect designed. So the network engineer's job will be to go out and, for example, a network architect might say you need 10 routers that can do these various things. But the network architect might not actually tell you which specific kind of router. They might or might not recommend Cisco or Granite or Extreme or Juniper or not, but the network engineer will know that. The network engineer will say, okay, in the design document here, I need to purchase 100 routers. 10 of them need to support these features and these interfaces. And so the network engineer will say, okay, I'm going to get Cisco for those 10 routers, and I know the specific model number of routers I want. For these other routers over here, I think I'm going to go with Juniper. And so the network engineer will order the equipment, know exactly what kind of equipment to buy. Then when the equipment comes in, a lot of times the network engineer will build a smaller prototype of the network. So instead of just going right out and installing 500 routers and 2,000 switches, the network engineer will take a look at the architect's design and say, okay, let me build a smaller scale of this and test it with like 20 routers and 75 switches. I'll build that in a lab and make sure that everything works okay. I'll connect it up. I'll do all the cabling. I'll do all the programming and configuring the devices, make sure it works. And then once it works, then the network engineer will say, we're good to go, and hand everything off to the network administrator. We'll talk about network admin in just a second. So, given this particular diagram right here, if we zoom in on this a little bit, what value would the network architect bring? Well, the network architect would sort of, even before all this is built, would ask questions, lots and lots of questions. How many users do you have right now? Where are they located? How do you see yourself scaling? What kinds of information will this network need to carry? How do you need to separate or group your traffic for security or quality of service reasons? And hey, let's even talk about your building materials. What are your walls made out of and your ceilings? Is it made out of brick or concrete? Is it made out of drywall, wood? That will affect your Wi-Fi, and that'll affect how I design the Wi-Fi portion of your network. And then based on all of that information that he or she gets back, he or she will draw up and create on paper, or not necessarily on paper, but maybe in Dropbox or something, the network that looks like this. Now the network engineer, this same network, now like I said, he performs proof of concept testing with either simulations or smaller scale mock-ups, decides on specific equipment models and software selections, purchases IP subnets, makes decisions regarding the design and implementations of smaller scale change requests. So all those things are what the network engineer does. Now, when you think, okay, I'm ready to start getting my first job in networking. I've got a couple of certifications under my belt. I've done some volunteer time at like the local library or college, and I've worked on their network under the supervision of somebody else. I'm ready to go out and get my first job. Your first job is not going to be a network engineer or network architect. They don't hire people for these positions who have virtually no experience. Your first job will most likely be as what's called a network administrator. This will be your entry-level position. Now I want to warn you, and that's what this first bullet point is talking about here. A network administrator most likely will not only be in charge of the network, but also hosts that connect to the network. As a network administrator, depending on the size of the company, and especially if you're working for a small to mid-scale company, you will probably also be expected to be in charge of their servers, understanding how to implement the email program on the server, implement the websites on the server, troubleshooting some of the problems that people are having with their laptops and PCs. A lot of times, network administrators in smaller companies have to do that kind of stuff too. It's really only work for a larger company, like 1,000 or more employees, when your network administrator can just focus just on the network. It's really only your larger companies that will have some employees just dealing with the servers and laptops and computers, and other employees just dealing with the network. You have to be hired into a pretty large company to get that luxury. So So the network administrator will be in charge of installing, configuring new equipment. So remember that large network I talked about where the network engineer said, well, let me create a smaller mock-up first. Mock-up works. Now the network engineer will contact the network admin. He'll say, hey, see that room over there? I got 500 routers and 2,000 switches. Here's a piece of paper. I need you to rack and stack these. I need you to go throughout the building and install these routers and switches in the various wiring closets and parts of the office as I've shown you here on this piece of paper. And I need you to cable everything together. Oh, by the way, here's the features and protocols that I want working. I want this, 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 and this. Here's a document stating how those features are supposed to work, what you're supposed to turn on, what you shouldn't turn on. You as a network administrator will not only have to physically cable and connect those things, I want you to program them. I want you to program the software to do this, like I've got in my mock-up right here. So installing, configuring, cabling equipment. Implementing change requests and implementing upgrades. If it's been, 2, 3, 4 years and the network's been going okay, but it's time to upgrade the software, chances are the network engineer will determine what version of software needs to be upgraded to. The network engineer will perform some prototype testing just to make sure there's no bugs or anything. But once the network engineer has identified the software to be upgraded, the network admin will have the job of going to all those routers and switches and doing the actual upgrade on those devices. Now, another entry-level position you might take on as your first job is a technical support engineer. And this is actually my first technical job that I did, but way back when I worked at Cisco Systems, my first technical job was as what they call a TAC engineer, or a Technical Assistance Center engineer. So technical support engineer deals with troubleshooting networking problems, but over the phone. So you're not actually going to be in front of the routers or switches. You're not going to see them. You're not going to be able to touch them. You may not even be able to access them, but you'll be talking to like your own internal employees or customers and sort of clarifying from them, asking them probing questions about narrowing down the problem, identifying the problem. And then you'll be asking them, the network admin, you'll say, okay, network admin, can you jump on router number 1 and type in this command, this command, this command, and then email me or instant message me the results of that command, the output. And then you'll look at the output and you'll try to spot what the problem is. And then you'll tell the network admin while you're on the phone or you're on the email, you'll say, hey, I think this is the problem I found. Here's why. I'd like you to type in these commands and let's see if it fixes it. So typically provides remote troubleshooting support. Don't really do hands-on installation of equipment, but this is a great job for providing foundational knowledge of software and network operating systems. All right, so you say, all right, I think I'd like to do that. I think I'd like to go for either technical support or a network admin, whoever will have me. Now the next question is, that's great, but are you right for the job? Do you have the right personality or characteristics to get a job in one of these fields? Well, let's talk about that. Who is right for the job? Number 1, you have to be highly organized. Take a look at your house. If your house looks like a tornado or a hurricane went through it, you might want to question whether you've got the personality to do this type of job. Okay? Number 2, enjoy learning new things. So this is not like, working at a gas station and pumping gas. That's a job you can do from the age of 20 till the age of 70, and it'll probably never change, or very, very little change. This is a job that's changing all the time. I sometimes used to watch Star Trek a long time ago. And, in Star Trek, you've got these transporters and teleporters and all this stuff. And, if something went wrong, Scotty knew exactly which panel to remove in the starship. And he saw all these guts and stuff, and he knew exactly where to go. And I used to think, wow, that technology is so advanced. What must they have learned in school in order to be able to get to the point where they could troubleshoot that kind of stuff? Networking is kind of like that. It's like moving at light speed, always going faster and faster and faster, always new stuff coming out. And so if you're actually working in a company where you have to monitor and troubleshoot networking stuff, you have to be on top of those latest trends. You have to be on top of what the latest stuff is. So hopefully you enjoy learning new things. You find that an invigorating challenge, a good mental exercise. willing to work off hours. This is one of the not so good things about the job. So if you're doing technical support or network admin, chances are if you have no seniority, if you're just starting out, they're going to get you to do the night shift, right? Or maybe you don't do the night shift, but there's going to be times when you have to come in at 3 o'clock in the morning on a Saturday or a Monday or something and do that software upgrade or swap out that one router for another router, because that kind of stuff, those types of activities can't happen during the day. Otherwise, it would cause downtime in the network, and downtime is bad, bad, bad. You want to avoid that. Critical thinker for troubleshooting. Okay, so you're at home and you are arguing with your spouse. Are you really sharp? Are you really good off the top of your head? You can have quick comebacks? You're pretty good with this. Are you just like, and you freeze and you don't know what to do? Okay, warning bells right there. Maybe you're not so good. So that's probably not a good example because that's an emotional context, right? There's all sorts of hidden wounds and things that affect your debating ability with your spouse. But for network admin or troubleshooting, you have to be a critical thinker. You're going to have people screaming around you, right? Especially if it happens in the middle of the day, something goes down. People are going to be ticked off. They're going to be stressed. You know, they can't answer the phone. They can't make those sales calls. They can't do their stock transactions. And they're going to be putting all their stress on you to fix that problem right now. And so you have to be able to put that stress aside and logically think through the problem, quickly identify a solution, and implement that solution. Okay. So you have to be a critical thinker. Works well with others. Yep, you're going to be working with other people to implement their change request, to troubleshoot their problems. If you've got an attitude that comes off like sandpaper on a baby's bottom, probably don't want to do this job. Okay? You want to be somebody that works well with other people. And you want to be able to sit in front of a computer monitor for extended periods of time. You know, this is not the type of job where you're going to be out smelling the flowers and roaming the hillsides all day long. You're going to be in front of your laptop here for hours on end, burning holes in your retinas. Okay? So that's just the nature of this job. It's all computer-based. Most of the time, you're not in front of that router switch. You're not standing. You're sitting. Most of what you do is right there from your cube. Now, if you still say, yes, this appeals to me, I think I could do that, I think I would like doing that, my characteristic, my personality seems to fall in line with this. Okay, how much money am I going to make, Keith? Well, all I can tell you is from the perspective of the United States. Now, I know a lot of you guys watching me right now are not in the United States, so I can't tell you from your local region, like in India or Russia or Finland, how much money you're going to make. But from the US perspective, these are some numbers I collected here for network administrator. So if you go onto these various different websites, PayScale, Glassdoor, SalaryOne, or IT Career Finder, you can see that the network administrator generally falls around, I found it to be like the $45 to $55 or $60,000 range. So that's US dollars, of course. Now, to get these types of numbers, you have to have a couple of certifications and a little bit of experience. As a matter of fact, I wasn't planning on sharing this, but let me see if it's still accessible for just a moment here. I created a survey in SurveyMonkey a few weeks ago. Good, I still have access to it. Okay. And I want to share these survey results with you. I reached out to all my LinkedIn and my Twitter contacts, and I asked them 3 basic questions. And I want to share with you the results of the questions. Question number 1 was, if a prospective employee had only one of these, which would you find more valuable and more likely to hire? It was either a CCIE certification or a college degree. And you can see the responses here. 75% of the people that responded said if they had to choose between just one, they'd rather hire someone with a CCNA certification and no college degree. 25% said, hey, I'd hire someone with a college degree only and without a CCNA. Question number 2. If you require new network admins to have both a Cisco CCNA, as well as industry experience. What is the minimum quantity of experience you'd consider acceptable? And you can see the breakouts here. You can see there's pretty much an even tie. Most people would prefer a minimum of 1 year or 2 or more years of experience. Some, 12% said, oh, 6 months of experience will be fine. But it looks like from the results here, you should have at least 1 year of experience. Now you might be asking, well, how the heck do I get that experience if I don't have a job yet? Hold on, I'll talk about that in my last section just coming up. And my third question, if in your opinion, a Cisco CCNA certification is not enough to hire a prospective employee into your company, which of the following below, along with a CCNA, would most tempt you to hire someone? And you can see the results here. So over half the people said that they would want someone to have a CCNA as well as a CCNP in routing and switching. That was by far the most popular answer. Then coming into second place was a CCNA along with a college degree in a related field. What I found kind of interesting is that of all the people who responded, absolutely nobody said that they would want someone who has a CCNA in routing and switching as well as a CCNA in a different specialty. That doesn't seem to appeal to employers, and that was kind of surprising to me. So, as this shows you right here, if you're going to pursue this, you're going to want to get yourself a Cisco CCNA certification, which involves passing 2 exams, and then you're going to want to go on to getting yourself a Cisco CCNP certification, which at present involves passing 3 exams. So you're looking at passing 5 different tests from Cisco, as well as having at least a year of experience before an employer will consider you someone that they want to hire. So the last section I'm going to go to is going to be, where do I go from here? What do I do now? So I will talk about that. So, but aside from that, let me take a look and see if you guys have any questions that I can answer for you. All right. So in my happy place, changing careers and getting into IT, you just got your BS and some certifications, but no experience. So you'll be happy to get anything to start. Well, that's a good attitude to have. And in the next section here, I'll talk about where can you go to get that experience when you don't have any. Green coder, how much daily configuration, maintenance, network admin work would a college LAN need? Aren't the routers and switches configured once and then everyone waits for them to fail? Generally speaking, that's partially true. Yes, usually once you apply your configurations, you don't go back continuously and change things. You're right. Once you apply your configurations, you don't really go into there and make any further configuration changes. But on the flip side, you don't just sit back and wait for them to fail either. That's where network monitoring comes in. So a big part of working as a network admin is network monitoring and network troubleshooting. So network monitoring, because you always want to keep your finger on that pulse, because the people using the network, you get employees that change, new applications come online that use a lot more networking bandwidth than you anticipated. People start using the network for things that are not allowed, like internet gaming, sharing of music and videos, whatever. So you want to be always monitoring that network to see if it's about to fail, right? The idea is to catch it before it fails, and network monitoring tools will do that. So a good portion of the day-to-day task is exactly that, monitoring the network, trending it, graphing it, making sure that it's well within the specifications of what it should do. Now you're also going to have a fair bit of network troubleshooting as well. Some of that is due to user error. People download viruses or whatever that cut them off from the network. A lot of it's from network attacks. There's network attacks that go on all the time. Even here at my company, I mean, we're in a small little office building here. We're a small little company of like 40 employees, and even our network gets attacked, which is mind-boggling. You think that people would attack like Cisco and the Pentagon and stuff, not some small little company like I&E, but it happens. So you can pretty much guarantee that network attacks will happen, and you have to be prepared for that. So a lot of the time also is studying, right? Learning new technology, getting prepared for that attack so you know how to mitigate it when it happens. Let's see, what other questions do you have here? So Olymp or Olymp, you say, do we need to study CCNP or CCIE routing and switching while networking functions are going to be decoupled and running in industry standard servers? And then you give some examples, NFV, cloud technologies, please give your suggestions. You're always going to have routers and switches. I don't foresee us moving to a time when servers do everything. When servers, for example, servers don't have hundreds of NIC cards. You're still going to have switches to connect your laptops and PCs into. Okay? Even if everything's doing wireless, all your access points have Ethernet cables that connect back to a switch. So you're not going to have servers that are branching out to all of your laptops and PCs. You're going to have switches doing that. Theoretically, and I don't see you having servers acting as routers either, because even though servers can do routing functionality, there's a ton of stuff the routers can do, like quality of service and security features and stuff, the servers just aren't designed to do. So I still see routers and switches being the main infrastructure of the network for decades to come. Now, it is true that the sort of momentum building is to use, is to get away from the need to log into individual networking devices, log into this switch, log into this router and program it, configure it, log into this one, log into this one. It's moving away from that. And sort of the ideal future that everybody's trying to get to, they're not at yet, is where you can have a server that dynamically discovers where all your routers and switches are, and then from that one central server, you can program those routers and switches. And you don't have to know the commands. The server has like a GUI, a graphical user interface, and via drop-down menus and buttons you can press, you can program stuff. I still, though, don't see that precluding the need to know the commands that the routers and switches need to know for several reasons. Number one, what if the server can't reach a device? Well, if the server can't contact a router or switch, you have to get into the network infrastructure to identify where's the breakage, which means you have to get into a router or switch to issue troubleshooting and show commands to figure stuff out. That still requires knowledge of the command line. If a router or switch is non-responsive, you still need to be able to get into it and issue commands to find out why. Right now, as we stand, the servers are running this software, still don't have the ability to program every little feature and every little keyword that you could do using regular Cisco IOS. It's sort of like, I guess the analogy I could draw is, there's a lot of applications out there that do voice to text, right? Where you can talk and it ends up typing what you talk. But there's still a lot of things you can do on the keyboard that those voice to text features can't do. For example, if you want to make a particular word red or blue, a lot of times voice to text can't do that. If you want to use special characters, voice to text can't do that. Same type of thing. A lot of this software that controls routers and switches can only do so much, but it can't do everything that the command line can do. So for the foreseeable future, I definitely still see there being a need for people to know that. So given that, should one pursue the CCNP or the CCIE? The vast majority of people out there, I would recommend get your CCNA first. CCNA is like the entry-level certification that Cisco offers. Then get your CCNP, and then go for your expert-level certification, your CCIE. If you've been in the networking industry for a while, and for a while I mean, oh man, a minimum of 2.5 or 3 years, then you might be able to go directly to the CCIE. As it so happens, the CCIE does not have any prerequisites. In other words, you don't have to pass any tests to get to your CCIE. You can go straight to the CCIE. But most people can't do that unless they've been working with these networking protocols and features for quite a while, and they can skip all those intermediary certifications. All right. And in my happy place, well, this is good information that you're typing in there. Thank you. A lot of the really entry-level jobs in the Seattle area are starting around $17 to $20 an hour and want some experience. Okay. So that's good information to know. All right, and how do we find online jobs in networking? So I would just go to your typical job companies like, Dice.com, Indeed.com. Those are two big ones that you can go to. There's a lot of others. And yes, Wade, very good point. Have you heard of the future networking engineer? A hybrid networking engineer needs to know some programming. Yeah, it's starting to move in that direction where a network engineer needs to not only know about the stuff I've talked about here, but also know about scripting. Maybe not necessarily programming so much, but definitely with scripting. A lot of times I get asked the question, do I need to learn Python? And you don't have to learn Python, but it absolutely would make you more acceptable to hire in the interview process. Python is a scripting language. You might say, what's a scripting language? I've never heard of that before. A scripting language is something like this. Let's say that you are frequently issuing the exact same set of commands to a set of devices over and over and over again. For example, let's say every morning when you get to work, one of your first jobs when you sit down is to issue like 10 commands across 50 devices. Collect all that output, scan through it, and you're looking for a particular keyword to indicate that something's going wrong or something's going right. Okay. So without scripting, you'd have to log into every single device one at a time, issue those 10 commands, collect all the information, put into a text file or something, and then somehow compare all those text files. A scripting language like Python enables you to create a script which will automatically log into each device, issue those 10 commands, extract the output from those commands, and the exact same script can be programmed to look for that keyword that you're looking for with just a push of a button. So network engineering is definitely moving in that direction, especially for companies that have really large networks. They have to manage lots of stuff. Scripting can make that job a lot easier and minimize those sort of repetitive tasks that have to happen over and over and over again. And Salim, you ask a good question right here. How to get motivated while working on critical and vast field of networking? So I'll answer that first question there. So if I'm understanding you correctly, and please correct me if I'm wrong, I think what you're asking is the field of networking is so vast. There's so many different facets and aspects to it. How do I prevent myself from getting overwhelmed? How do I prevent myself from getting depressed that there's so much stuff and I could never possibly know it all? Well, think of a doctor, right? A doctor could run across that same problem, right? A doctor could say, oh my gosh, there's everything to know about the heart and about the brain and about blood cancer and cancers and this and that and the other thing, and skin and plastic surgery. How am I ever going to know it all? Well, you're not expected to know it all, right? Like, when a doctor's going through medical school, initially he or she will be exposed to a wide range of stuff, just like you. When you're studying networking and you're studying for your certifications, you're going to be exposed to a lot of different things. In the CCNA and the CCNP level, all different kinds of things. But ultimately, like a doctor, when a doctor's going through medical school, somewhere in those years of medical school, he or she decides, hey, you know what? This field really fascinates me. I'm really interested in this. So even though my major might require that I take quite a few varied classes, I'm going to emphasize in this. Same type of thing with networking. Yeah, with networking, it's a good idea to know a little bit about a lot of different things, right? To know a little bit about routing protocols, a little bit about voice over IP, a little bit about security, a little bit about data center. But ultimately, you're going to choose something that appeals to you. Of all these different topics, something will stand out. You'll say, you know what? Video really fascinates me. I'm really fascinated about how video goes over a network, and you can start specializing in that. So don't worry about all the stuff you don't know. Just find some aspect of networking that interests you and really pursue that. That's all I can advise you on that. And can a network engineer have a normal life out of the networking life, work pressure, and complexity? That all depends on the company you work for and the manager that you have. I'm sure that's absolutely true. I mean, you're not going to be called in every single day at 3 o'clock a.m. to troubleshoot problems. If that's happening, that means somebody's not monitoring the network. That means somebody's job whose network analysis and network monitoring is failing in their job. Problems should not happen that often. So you should be able to have a normal life. And Carlos, you said, what is the hottest field in networking now and in the next 10 years? And what skills do you think we should be looking at to get ready for the future? Well, it's kind of hard for me to predict 10 years. In the world of networking, 10 years is like a lifetime. Things will be so much different 10 years from now than they are right now. It's virtually impossible for me to predict that. I can probably predict the next 5 years, though, somewhat well. So I would say some of the hottest topics in networking right now are security. Security is way up there towards the top, and probably data center. Knowing how to connect a network to the data center and get all those servers and everything working with the network. So those are probably the two hottest topics, security and data center right now. Network virtualization and software-defined networking is definitely the big push right now. Cisco is really pushing that. A lot of other companies are pushing that. So probably over the next 5 years or so, that's going to become more and more prevalent. The virtualization of routers and switches within servers and software-defined networking, controlling everything from one server. So I would say that. And Olymp, unfortunately, I can't. I mentioned at the beginning here, you may not have been around to hear me. I can't really advise you on CCNA security versus cybersecurity. I have not seen the cybersecurity. I don't know what is tested on that. How can we survive in this competitive world of networking by just having knowledge on a specific technology? Because interviewers expect a lot from you. How to come out of it? Well, what I would recommend is spend a little bit of time over the next few days or the next week just looking at available networking jobs in like dice.com, indeed.com, and other online websites like that, and sort of scan the jobs and try to find similarities. For example, I mentioned earlier, a lot of networking openings say firewalls in there, VPN in there, routing in there. Try to find that, and that'll give you a good idea. Now, you're not going to be able to learn everything, right? But you should be able, after looking at like 40 or 50 job openings for network admins, and just focus on network admin, don't look at architect or engineer, just look at network admin. After looking at 40 or 50 job openings just across the country, or in your country, whatever, you should be able to pull out of that like 4 or 5 keywords that you see a lot. And then once you have that, focus on that in your studies. Now, like I said, if you're just starting out in networking, for example, you're probably not going to learn about firewalls. You're not going to learn about VPNs when you very first start out. The Cisco CCNA exam doesn't really cover those. It expects you to know what those terms are, but it doesn't cover them in any sufficient depth whatsoever. You really got to get up to like the CCNP level to get into that. So just expect that when you're studying for your first certification, you're going to be learning a lot about a lot of different stuff to a minimal level of depth, a lot of different things. Then when you get to your CCNP level, you're going to be going into a lot more depth, but still you're probably, of those 5 or 6 keywords you pulled out of those jobs, you'll probably only be covering like 1 or 2 of those keywords even at the CCNP level. So really, to hit those 5 or 6 keywords, you're going to want to be studying that stuff on the side while you're preparing for your CCNA and your CCNP. And then once you have the job, once you actually are employed, it's just a process of continually learning, right? Whenever you have some downtime, reading network journals, go to Network World. That's one that's really popular, and lots of other ones as well. And just keeping up to date. Visit Cisco's website often and read what they have on their front page. And just keep up to date on what the newest trends and developments are. And that'll give you a feel as far as what you should be researching next. All right, so I'd like to go into my last topic now. So in this last section, I've titled it, Where Do I Go From Here? What do I do? Okay, so some next steps. And this is pretty basic, but this is what I was able to come up with right here. Okay, so the primary thing is you're going to want to talk to someone, right? And I would start by identifying a network admin at your work or school, if you're currently in college, or at your work. But try to find someone who's doing this job, okay? And then once you find them, say, let's say it's, John. You say, hey, John, you don't know me. I work at the company, and I'm fascinated by what your job is. And at some point in time, I'd like to do what you're doing. Would you mind if I buy you a cup of coffee or dessert at Starbucks something, and maybe we could sit down for half an hour and I could just pick your brain a little bit? Everybody likes to talk about themselves, right? If you offer to buy someone coffee and a dessert and give them the opportunity to talk about themselves, of course they're going to say yes, right? Unless they're a complete jerk, in which case you don't want to deal with them anyway. So now you're sitting down with John across the table at Starbucks or wherever you are, and these are the types of questions you want to ask him or her. Tell me about your job. What do you do on a day-to-day basis? What do your days look like? What do you like about your job? What are some things you don't really like about your job, if you'd be transparent enough to tell me? What kind of experience did you have before you got hired? What experience did you have that helped you get the job? What skills do you consider important for your job? If you were to leave your job right now and somebody had to fill your shoes, what skills would you expect them to have to be able to do what you do? And if you were to provide like a verbal roadmap to someone, as far as, like you say, hey, John, right now, I don't know anything. I'm just starting out. I just bought my CCNA book. I've read like the first 50 pages. That's where I am. If you were to give me a roadmap, how could I get from where I am right now to doing what you do? And let John suggest some ideas. Another thing you can do is watch some YouTube videos. There's a guy on YouTube that's got his own channel called Eli the Computer Guy. I'm sure there are others as well. But Eli the Computer Guy, one of the things he does, among many things, is he interviews people. And a lot of times he interviews network engineers and he asks them these exact same questions and more. And so by watching some of these interviews of some of these network engineers, you don't even have to buy them coffee. You can just sit down, watch the videos, and get answers to these questions right there. So this is the idea, is that you want to get sort of an idea of how did they get to where they are and express that interest. Now, once you know that, you're going to want to start studying. Now, like I mentioned, there are a lot of networking vendors out there. Cisco is not the only one, but pretty much Cisco's certifications, even still to this day, are known as like the preeminent certifications. You know, if people are looking for a networking certification, almost always in their job listing, they'll specify a Cisco certification as well as maybe one or two others as well. But Cisco certifications won't fail you. Now, as far as Cisco certifications are concerned, if you're not familiar with those, let me just show you real quickly here. So if we go to google.com and we type in Cisco certifications. All right, certifications, training and certifications from Cisco. Let's make this a little bit bigger here so you can see it. Okay. So I'll make this a little larger here. So the first certification you're going to go for is the CCENT, which stands for the Cisco Certified Entry-Level Technician. So that requires only passing one test, which is called the ICN, can't write on this thing, ICND 1 exam. So by passing the ICND 1, you get your CCENT. Then there is an ICND 2 exam. Once you pass both of those, you get your CCNA in routing and switching. Okay. Now, I'm not sure about all of these, but I know most of these here require you to have a CCNA in routing and switching as a prerequisite. For example, CCNA security, you can't get your CCNA security unless you already have an active CCNA routing and switching. So that's why I'm really pushing that one for you. Now, once you got your CCNA routing and switching, remember that survey I did? And I said, hey, if you require more than one certification, and nobody said, oh, I'd like a CCNA routing and switching and another CCNA in something else. Nobody said that that was valuable to them. So don't waste your time after getting your CCNA routing and switching by going for another CCNA in something else. Don't do that. So once you get your CCNA routing and switching, then you're going to get your CCNP. So you've got your CCNA routing and switching, and then you're going to want to get your CCNP in routing and switching. So certification-wise, that's the minimum level of certification you're going to want to get. CCNA and CCNP in routing and switching. Now, if you want to get more above and beyond that, go for it. But that's the minimum you want to do. Now, while you're doing that, you're also going to want to be playing with this stuff. You're going to want to be creating labs and practicing it, because both of these certifications require not only that you know how the networking protocols and features work, but they also test you on, do you know the commands in Cisco routers and switches to make these features work? And the best way to learn the commands is by doing it, by actually labbing it up and doing it yourself on routers and switches. I would recommend that you buy yourself a little mini lab, and it doesn't have to be a lot of stuff. So for example, right here, I'd recommend that you purchase 2 routers and 1 switch, an absolute minimum. I just looked just earlier today, and right now a Cisco 3725 router, you can get that for as little as $40 US, and you can get a 3560 switch for like $20. I couldn't believe how cheap they were. So for just about $100, maybe a little bit more, you can get a little basic lab. Now, it'll probably be more like 120, 130 once you add in the cables and maybe some other miscellaneous things that you need, like a small little rack or something. But for roughly $150, you should be able to buy yourself a cheap 3-node lab, 2 routers and a switch. Now, why am I saying that you need a physical lab? Well, because there's some things that you can do on a physical lab that you just can't do in simulated environments, and you just can't do when you're renting time on other people's racks. For example, getting familiar with how to connect to a console port, getting familiar with the lights on the routers and switches, the LEDs. What does it mean when they're green? What does it mean when they're red? What does it mean when they're yellow? When they're blinking fast or blinking slow? You can't see that stuff unless you're right physically there. Getting experience with cabling and all the problems that can occur with cabling. Getting experience with software upgrades and software downgrades. That's something you really need to be physically in front of to do. Password recovery. When you lock yourself out of a router switch, the process to circumvent that or to get around that, you have to be physically right there in front of the device. And sniffer traces, getting packet captures and things like that. It's a lot easier to do that with physical devices. Now, in addition to that, with just this basic lab here, you can do all this stuff, right? So for $150, you can get experience with these bullet points right here, with these 2 routers and 1 switch. But really, to practice a lot of the features and protocols you're going to learn at the CCNA and the CCNP level, you're going to need a more sizable lab, something bigger. Now, you could build something bigger on your own, but there's lots of ways that you can get around that. So for example, if you go to that YouTube playlist right there, I just want to show this to you real quickly. So here at I&E, if you go to our website, you'll see one thing that we offer is rack rentals. So right there under Training Solutions, we have rack rentals. And what this means is we have racks and racks of equipment that you can rent from us on like an hourly basis. And it's pretty cheap, pretty inexpensive to do that. So when you click on rack rentals, you'll see that the first step is purchasing something called rack rental tokens. And we have sales on tokens all the time. But this is the current list price on tokens. The minimum quantity of tokens you can get is 100, which would be $100. 1 token equals $1, and you can go up from there. But believe me, we have sales all the time on tokens. It wouldn't surprise me if in the next week or 2 or 3, we have some sales on that. Once you get some tokens, then you're going to want to choose a particular lab rack to rent some time on. And at your level where you are right now, what you're going to want is you're going to want to rent some time on the CCNA, CCNP routing and switching rack. And that'll give you access to 4 routers and 3 switches already cabled up and ready to go. And then you can just rent that on an hourly basis. Real easy to do. And then once you have, that rack, you can either make your own labs, practice your own stuff, experiment, play around, or you can purchase, for example, one of our lab workbooks. If you've never seen our lab workbooks before, let me just show you what that looks like real quickly. All right, so workbooks. So let's say you're practicing for the CCNA, which is where you're going to start, and the ICND1. Okay, so for example, this is what the workbook looks like. Each one of these things here in orange is what we call a lab task. So you see there's multiple tasks. So for example, if I click on task 1.6, this is the topology. This is the topology you're going to be working with. So all these labs are built assuming that you are renting time on our equipment. So you just basically try to do this. So this is testing your knowledge. Do you know the commands to accomplish this? And then once you're finished, or if you get stuck, you just click on right here where it says click to expand, and it talks about, okay, here's what you needed to do. Here's the commands you need to type in. Okay, and here's verification. Here's how you would have known if you'd got it correctly. So these workbooks are really good for sort of guided labs if you have a hard time coming up with labs on your own. And we talked a little bit about Cisco certifications already. I talked about the entry level, the associate, professional, and then even higher up than that we have the expert level certifications, and then we have the architect. The architect is like crazy. There's less than 12 people in the entire world who are Cisco certified architects. That's like a massive, massive long-term goal if you want to pursue that. And like I mentioned with one of the questions that somebody had earlier, all the certifications that have CCD are for design. So there's CCDA, Design Associate, CCDP, Design Professional. I would recommend, though, that even if you're interested in design, because remember, you are not going to get an entry-level position that has you designing networks. It's not going to happen. No one's going to hire you for that right off the bat. That requires years of experience. So before you do your CCDA, I would recommend you do a CCNA followed by a CCNP. You really have to learn the features, the protocols, how they work. When a trigger happens, it causes this event to occur. When this happens, it causes this trigger to occur. You have to learn all that stuff. And that's where you learn it in these certifications right here. You can't really understand how to design something unless you first understand how it works. And so the CCDA, if you wanted to, then you could go to CCDA after that for design. All right, let me see if there are any final questions that I can answer today. So Green Coder, you asked, does a CCNP learn about software-defined networking? If not, at what level should I expect to learn this stuff? So my experience is within routing and switching. I have not taken any of the other exams, so I've done the CCNA, the CCNP, and the CCIE all through the routing and switching track. And you don't really learn about software-defined networking. They introduce the term, they introduce like 5 or 6 vocabulary concepts, and they sort of give you some screenshots of what it looks like, but that's about it. So I don't even know if they have a certification that deals with software-defined networking and all the intricacies of it. That's a good question. I don't think Cisco currently has a certification that really gets into that in any great detail. They probably will, but I don't think they do right now. So I've mentioned, Toivo, I've answered your question about what certifications a network admin should have, a minimum of a CCNA and a CCNP. So Mario, Cisco recently released some new self-learning courses. Are they worth it? For instance, as a data center network engineer, I'm interested in CCNP data center modules, but they're really expensive. Is that $1,500 each? That's insane. I can't speak to if they're worth it or not. I haven't seen them, so I don't know if they're worth it or not. I'm sure they're very high quality. I'm sure they're good. But for me personally, the best learning comes when I can have some interactivity, some sort of feedback. So if those self-learning courses also provide, for example, links to where you can ask a mentor, ask an expert, and you can ask your questions and get answers pretty quickly, then that would be good. But if they don't have that, it's going to sort of leave you out in the cold if you're watching it and something confuses you, it's kind of ambiguous and you don't know where to go. So I don't really know how to answer that, unfortunately. Are there any virtual labs available? So Joshua asks. Yes, there is some software you can get to do virtual labs. So if you're, once again, if you're just starting out, and if your intention is to get a Cisco CCNA certification, then you can download for free some software from Cisco called Packet Tracer. So let me show you. If you just go to Google and you type in Cisco Packet Tracer download. So you'll have to first register for Cisco's Networking Academy, but that just basically means give them your email address, create a password, and that's it. You don't have to enroll in any courses, you don't have to go to any buildings, just register. And then once you register, then you can download the Packet Tracer tool. And Packet Tracer, I believe I have it here on my laptop. Yes, I do. So when you run Packet Tracer, it's a completely simulated environment. So here it is. And so from here you can just, for example, just click on a router, put in your topology, and you can create topologies that you want of these various different devices. You can put some switches in there, and you can connect them together. That connection there, going to that connection right there. And you can build out these topologies, and then you can get into the routers and switches and practice stuff. Use Cisco iOS commands to practice the iOS commands and get used to them. Now at the CCNA level, the entry-level certifications, this is fine. This will provide you like 90%. This will allow you to practice about 90% of the commands you would need to know for your CCNA. Now, if you are concerned about the remaining 10% that you don't have access to, well, in that case, you can either rent time on our racks to get that, or as far as routing commands are concerned, commands on routers, you could download another software. Let's see here, where is it? You can go to Google and type GNS3. Let me zoom in on that a little bit so you can see it. GNS3. And GNS3 is an emulator. So you can download this for free. Same thing, you have to create a user account on their website and then log in, then download it, download for free. But GNS3 as an emulator, which means that you have to somehow get a hold of real Cisco software and import it into GNS3. And then when you do that, you essentially have a router on your desktop. You can create topologies with routers inside them running real Cisco iOS software. So the router commands that Packet Tracer doesn't support will absolutely be available in GNS3. Unfortunately, some of the switching commands are still not available. Switching is still kind of light in GNS3. So where does that leave you? Well, at that point, you have to pay some money. And you can either pay it to us to rent our racks, or Cisco also has something called Viral, which stands for the Virtual Internet Routing Lab. And they have a Viral Personal Edition, which runs $200 for a 1-year subscription. And with that, you can actually create, once again, emulate topologies with routers and switches. I'm just not sure that someone at the CCNA level would want to pursue Viral. It's a little complicated to get going, a little complicated to work. I would just stay with Packet Tracer, honestly. All right, what other questions here? And Dynand, yes, INE provides labs to practice, so I talked about that. We have rack rentals and we have lab workbooks that you can use along with our rack rentals to practice the lab, so we absolutely have that. Dialer string, good to know. So at Mario, so you dialer string, you've got the CCNA data center modules, and they're in depth, but kind of boring. So good. Thank you for providing that feedback. Good for us to know. All right. So with that, that does bring me to the end of our session today. So I've covered everything I wanted to cover. And I really appreciate all of you joining me today. I appreciate your questions. Hopefully, if you knew nothing or very little about networking, this shed some light on it from what I was talking about, and shed some light on some potential job roles, and maybe spark some curiosity in you to go further down that pathway. If you are interested in pursuing a Cisco CCNA, we have lots of videos. We have video packages you can buy, and every single month, I do what's called a CCNA kickoff show, and where I talk about what's it like to get a CCNA, what does the exam look like, what do the questions look like, what are some strategies for preparing and some tips to make your studying process easier, how long is it going to take you, how much is it going to cost. So if that's something that interests you, if you create a free INE account, INE.com, and you create a free account and then you log in. Once you log in, it'll take you to this. This is what's called the members dashboard. And on here is our calendar of upcoming shows. And so I already did one for May. So in a couple of weeks, I'm going to do a show on spanning tree. So if you're currently pursuing your CCNA and you want to learn more about spanning tree, I'm going to have a show just on that. But if you go into June, my next... Where is it? Thought there was one for June. Maybe it's not in here yet. Let me just look on my own personal calendar here real quickly. Okay, June. Well, it looks like we don't have one. Looks like June hasn't been scheduled yet. So I can tell you we will have one in June. Every single month we have these shows. So just check back on this calendar. Check back in a week or two, and you'll see here somewhere in June it'll say CCNA Kickoff, and you can watch my show then. Also, our previous CCNA Kickoffs have been recorded and are available. So if you go to our YouTube channel, so INE training. If you go right here, and let's see here. And you go under videos. So right here, here's the last CCNA kickoff. So this one in May that was done. So that was just, whoop, that is a problem with YouTube, I think. But anyway, it was there. So you can search for that. That is playable, as well as the one from April and March. They're all in there. So thank you everybody for watching the show today. Like I said, I hope you found it to be beneficial, and I will see you again during our next show. Have a good week.